As a part of revision class series, day before yesterday, I have completed programming language course. And yesterday we covered some of the important areas in data structures. Today I take this opportunity to discuss some of the important areas in algorithm subject. Okay. See, I'm planning to discuss topics like sorting algorithms, which is common for both DA and CSC students. And it is the highest weightage topic in algorithm subject, friends. Okay. So first topic is sorting algorithms, where I will focus on bubble sort, selection sort, insertion sort, merge sort, quicksort, and then heap sort. While I'm discussing heap sort, I'll explain main important aspects of heap tree also. This is also very important topic for you. Okay. And afterwards, next topic is spanning tree. So DA students point of view, this topic comes under graphs, basics of graphs. Okay. So spanning tree. Under spanning tree, we are having algorithms like Prim's algorithm and Kruskal's algorithm. So you believe me, without having spanning tree question, there is no gate question paper so far. So this is the highest priority topic in algorithm subject. Suppose if the tomorrow is a gate exam, then definitely you have to give first priority to spanning tree and then sorting algorithms, friends. Okay. Next one is shortest path algorithm, which is common for both D and CSC students. That is Dijkstra's algorithm, Bellman-Ford algorithm, and all-pair shortest path algorithm. This all-pair shortest path algorithm also known as Flad-Warshall's algorithm. Okay. So after that, if we have time, we'll focus more on searching algorithms, like how linear search is working and how binary search is working, and what is the difference with respect to time complexity, and what is the difference with respect to recurrence equation. So different aspects we'll discuss in searching algorithm, friends. Okay. Next one is time complexity. So if time is there, I'll introduce master theorem concept also. Okay. Still, if you have time, we'll cover time complexity based on simple loops, and time complexity based on nested loop. Today I'll reduce the break time. Okay, instead of 30 minutes break, today I'll take only 20 minutes break. First break 20 minutes, whereas second break only 15 minutes, so that I can cover more number of topics in a given stipulated time period. Okay. So could you please someone confirm that are you able to hear me properly and is everything is clear? Let me check. You have access in chat also, so you can post your queries in chat. Yes, right. Okay, thank you. The first topic which we are going to discuss, that is sorting algorithm concept, friends. Okay, sorting algorithm concept. Actually, sorting algorithm concept, while I'm discussing merge sort algorithm, quicksort algorithm, and heap sort algorithm, I need to write recurrence equations. Okay, recurrence equation. That is reason first I'll introduce how to solve recurrence equation by using master theorem. Because without having master theorem concept, I cannot explain quicksort, merge sort, and then binary search algorithm, friends. Therefore, first I'll teach master theorem, so that you can recall all different cases of master theorem. So with that, we will move to the concept of sorting algorithm, friends. Okay. Generally, this master theorem concept, where we will discuss in divide and conquer technique. Suppose if T of n is equals to A into T of n by B plus theta of n power k into log to the power of Pn to the base B, where A value is greater than 0, B value is greater than 1, k value greater than or equal to 0, and P is any real number. P is any real number means we can allow negative numbers also. P is any real number. So whenever given recurrence equation falls under this category, in that case there are three different cases in master theorem. First case, if A is greater than beta to the power of k, if A is greater than beta to the power of k, then T of n is equals to, you also think about the solution, friends, okay. Simultaneously you can do the revision. And the second case, case number 2, if A is equals to beta to the power of k, and again there are three subcases are there. First one, p value greater than -1, then T of n is equals to, that is the first point, okay. And the second point is, if p value is equals to -1, then T of n is equals to, whereas third case, p value is less than -1, then T of n is equals to, right, friends. So first case A greater than beta to the power of k, second case A equal to beta to the power of k. In second case also we are having three subcases. And the third case, case number 3, if A is less than beta to the power of k and p greater than or equal to 0, please excuse me, if p greater than 0, then T of n is equals to theta of, so we will discuss what is that value. Next, second one, if p value less than or equal to 0, then T of n is equals to. Most of the recurrence equations falls under this category. In that case only we can apply master theorem, friends, okay. There are some situations where recurrence equation not falls under this category. For those recurrence equation we cannot apply master theorem, clear. So what are the different types of equation which are not falls under this category means, see, just observe. Suppose if you are having recurrence equation, T of n is equal to, T of n equals to 2 into T of n by, that is 2n by 3, n by 2 plus theta of n square. Suppose if you have a recurrence equation in this format, if you convert this recurrence equation in the standard format and compare with the constants a, b values, where a equals to 2, a value equals to 2, what about b value? B value is equals to, you can rewrite this equation as 2 into T of n by 2 by 3 plus theta of n square, right, friends. So what about a is equals to 2 and b equals to 2 by 3, right. So here a equals to 2, b equals to 2 by 3, but the restriction for master theorem is b must be greater than 1. The reason why b greater than 1 means then only work is divided among the people, okay. Suppose if b equals to 1, it cannot be divided, work cannot be divided among the people. That is the reason it is compulsory we have to take b must be greater than 1. But here b equal to 2 by 3, which is not greater than 1, friends, okay. So therefore not greater than 1, hence master theorem is not applicable in this case. This is the first case you have to remember, okay. And the second one, suppose if you take T of n is equals to something like 2 into T of n by 3 minus of n square. Here negative functions are not allowed in master theorem. Negative functions are not allowed in master theorem. So therefore here also we cannot apply master theorem, right. And third case, suppose T of n is equals to 2 into T of n by 2 plus something like theta of 3 power n. It is exponential time, friends, okay. 3 to the power of n means exponential time, where here we are expecting always polynomial time complexity, okay. So for exponential time complexity we cannot apply master theorem. Directly I can say it is a dominating value, hence the time complexity bounded by theta of 3 power n only. Here we cannot apply master theorem, okay. So these are certain cases we should understand where we can apply master theorem, friends. Okay. Now we'll discuss different cases of master theorem. Suppose if a greater than beta power of k, then T of n is equals to formula theta of n to the power of log a to the base b, n to the power of log a to the base b. Suppose if a is equal to b power k and p greater than minus 1, simply write down solution of the first case as it is, theta of n to the power of log a to the base b. Okay. Even p is equals to minus 1 also we can write theta of n to the power of log a to the base b. Means if you remember first case answer, second case, third case is so easy. And second case again third bit, it is theta of n to the power of log a to the base b. Clear, friends? Okay. But in second case first bit, if p greater than minus 1, in addition to theta of n to the power of log a to the base b, we will have log to the power of p plus 1 n to the base b. Right, friends? Okay. Here additional term is, it should be multiplied by log n to the base b. Clear, friends? Okay. Here there is no multiplication factor for multiplying them. That's all. Okay. Next, third case, if a less than beta power of k, if you could remember the statement, from the statement we are having theta of n to the power of k log to the power of p n base b, right? So that case we can write here as it is. We can copy this part as it is. N to the power of k into log to the power of n to the base b. Right, friends? Okay. Suppose if p less than or equal to 0, p less than or equal to 0, p less than or equal to 0 means put simply p equal to 0 in this case, because it is taking less than or equal to 0, right? How you remember this one? Simply put p equal to 0. If you put p equal to 0, you will get theta of n power k, theta of n power k. Clear? So these are different cases in master theorem, friends. Okay. Is it clear, everybody? Could you please respond? Yes. Without having master theorem, we cannot discuss sorting algorithms. That's why I started with master theorem. Yes. Now we'll solve questions based on this topic, friends. Okay. Suppose they may ask the question, T of n is equals to 4 into T of n by 2 plus n into log n. They may ask question like this. Okay. So first to compare this equation with the master theorem. By comparing the master theorem, we can write it as a into T of n by b plus theta of n power k into log power p n to the base p. Right, friends? Okay. So by comparing the standard form, a value is equals to 4, b value equals to 2, where k is equals to, we can write n to the power of k, that equal to 1, right? So k value equals to 1 and p value is equals to 1. Now verify is it belongs to first case, second case or third case. So first one is a greater than beta power of k. A means 4, b means 2 and k means 1. Yes, a greater than beta power of k, condition true. Hence it belongs to case number 1. Case number 1 answer is T of n is equals to theta of n to the power of log a base b, n to the power of log a base b. So we can also write it as 2 square, bring square here, log 2 base 2 value equal to 1, therefore hence it is theta of n square. Okay. This is the first question based on master theorem, friends. Okay. Next question, question number 2. Suppose if T of n is equals to 2 into T of n by 2 plus log n, 2 into T of n by 2 plus log n. Again compare the master theorem and get the constant values a, b, k. A value equals to 2, b value equals to 2 and k equals to 0 and p equals to 1. Right, friends? Okay. Now verify the condition is a greater than beta power of k. Yes, 2 greater than 2 power 0, which is true. Therefore, it belongs to case 1. In case 1, T of n is equals to theta of n to the power of log a base b, which equals to theta of n. Theta of n. Clear, friends? Okay. Next, third one, T of n is equals to three into T of n by 2 plus root n. 3 into T of n by 2 plus root n. Just compare the standard form of the master theorem and get values of a, b, k. A value is equals to 3, b value equals to 2, and k equals to 1 by 2. Because we can write this n to the power of 1 by 2, right? N to the power of 1 by 2 means k value becomes 1 by 2. But p value is 0 this case. P value equal to 0. Right, friends? Okay. So therefore, verify is a greater than b power k. Of course, yes, because 3 greater than 2 power 1 by 2, which is correct. Therefore, we can say it is true. So it falls under category of case 1. Therefore, T of n is equals to theta of n to the power of log a base b, that is log 3 base 2. Right, friends? That is a third problem in master theorem. Okay. Next, fourth problem, T of n is equals to 2 into T of n by 2 plus some constant c. Some constant c. If it is constant value c and n to the power of k is absent, log to the power of p also absent. Okay. So therefore, verify is a greater than b to the power of k or not. So 2 greater than 2 power 0, because a constant, right? Constant means we can write n power 0, log power 0. So k value is 0, p value is 0. 2 greater than a greater than b to the power of k. So 2 greater than 2 to the power of 1. Sorry for the mistake. 2 greater than 2 power 0. Yes, it is true. So it belongs to case number 1. Therefore, T of n is equals to theta of n to the power of log 2 base 2, which equals to theta of n. So these are 4 different types of questions in first case of master theorem. See how I explain this problem. In first case, both k and p are present. Both k and p are present, right? Where in the second problem, k is absent, p is present. Third problem, k is present and p is absent. Right, friends? Okay. And fourth one, both k and p are absent here. In this case, both k value equals to 0 and p value also 0, because we can write it as n power 0. Therefore, by comparing with this master theorem, we have a equals to 2, b equals to 2, and what about k? K equals to 0 and p equals to 0. Right, friends? Okay. So whenever you find any question in master theorem, first verify is it belongs to first model, second model, third model, or fourth model. Clear, friends? Okay. Next one. Problems based on second case. The problem number 5. T of n is equals to 4 into T of n by 2 plus n square into log n. 4 into T of n by 2 plus n square into log n. Just compare the master theorem. You'll get a value equals to 4, b equals to 2, k value equals to 2, and p value equals to 1. N to the power of k, log to the power of p, n. Here base is not required to show every time, because in algorithm subject base is not having any impact. Okay. Because for example, if you write theta of log n base 2, why we are not focusing on base means we can write it as theta of log n base 2 means we can write it as log n by log 2. Correct, friends? Log n by log 2. Log a to the base b, we can write log a by log b. In the same way, log n base 2 means we can write log n by log 2. But within asymptotic notation, there is no importance of the constant log 2. Therefore, it is reduced to theta of log n. That's why you no need to give importance of this base. Okay, you don't give importance of that base value. Right, verify is a is equals to b power k or not. 4 is equals to 2 power 2. Yes, a is equal to b power k condition satisfied. Then it belongs to case 2. But under case 2 again we are having 3 subcases, right? So therefore p is equals to 1 means which is greater than minus 1. P value is greater than minus 1. So therefore it belongs to second case. Under second case it is the first bit. Therefore T of n is equals to theta of n to the power of log a base b into log to the power of p plus 1. So p plus 1 means 1. 1 plus 1 log to the power p plus 1 n base 2. Clear friends, okay? By simplifying we'll get result as theta of n square into log square n base 2, because log 4 base 2 means we can write it as 2 square, we can get 2 here. So n square into log 2 base 2, log 2 base 2 value is 1. So this is the first one. Next, sixth question. T of n is equals to square root of 2 into T of n by 2 plus square root of n into log power minus n base 2. Right friends, okay? Now compare this problem with the standard theorem of the Master theorem. Now a is equals to square root of 2, b equals to 2, k value equals to 1 by 2 and p value equals to minus 1, right? Therefore verify is a is equals to beta power of k. So square root of 2 is equals to square root of 2. Yes, a equal to beta power of k condition satisfied, and p value exactly equals to minus 1. Therefore it belongs to case number 2. Under case number 2 it belongs to second bit, right? If it is second bit, then T of n is equals to theta of n to the power of log a log square root of 2 base 2 into, it is case 2 second bit, right? So n to the power of log a to the base b into log base b of log n base b. Right friends, okay? I can write 2 to the power of 1 by 2, bring 1 by 2 here, so n to the power of 1 by 2. So therefore it will be further reduced to theta of square root of n into log base 2 of log n base 2. Clear friends, okay? Next question. Suppose if I consider T of n is equals to T of n by 2 plus log to the power of minus 2 base 2, log to the power of minus 2 base 2. Therefore verify what is a value. A is equals to 1, b equals to 2 and n power k, k value is 0, log to the power of p, p equals to minus 2. First verify is a equal to beta power of k or not. Is a equals to b power k. So 1 is equals to 2 power 0. Yes, it is true. And what about p value? P value is less than minus 1, correct? P equal to minus 2. Minus 2 is less than minus 1, which is correct. Therefore, it belongs to second case. Under second case, it belongs to third bit. Therefore, T of n is equals to answer theta of n power log a base b, which equals to theta of log 1 value is 0. So n power 0, that equal to 1. So it will take only constant time. So therefore we successfully covered 2 cases friends, okay? First 4 problem belongs to first case and remaining 3 problems belongs to second case, okay? Next, 8th problem. T of n is equals to 4 into T of n by 2 plus n cube into log n, n cube into log n. Just find the values of a, b, k. here a equals to 4, b equals to 2, k equals to 3 and p equals to 0. P equal to 0, right friends? Okay. Now verify the condition, is a less than b to the power of k or not? 4 less than 2 power 3, yes. What about p? P exactly equal to 0, so p less than or equal to 0 case. Since p less than or equal to 0 case, no, how it is p equal to 0? Please excuse me. Please excuse me friends. So log p is equals to 1 here, right? P equal to 1. So therefore 4 less than 2 power 3, yes it is true. And p value is greater than 0. So therefore it belongs to which case? It belongs to third case. And the third case it belongs to first one. Therefore answer to this question is T of n is equals to theta of n power k into log power p n base b. Means from the statement of the master theorem only we copy this part as it is friends, okay. So therefore whatever answer we are having here, that is only final answer here. Therefore theta of n cube log n base 2. Clear friends, okay. Next question, that is the last question. T of n is equals to, let me keep it as 8 into T of n by 2 plus n power 4. Verify the condition, is a less than b to the power of k. 8 less than 2 to the power of 4, yes, right. What about p value? P value equals to 0. Therefore it belongs to case number 3, second bit, right friends, okay. Then answer to this question is T of n equal to theta of n power k n power 4. That's all. That is the final answer. So you can expect questions based on this topic in this way. There are so many questions are there in master theorem friends, okay. You have to practice questions like this. One time in the gate paper they provided a flow chart. For that flow chart they are asking what is the worst case time complexity. If the worst case time complexity bounded by order of n to the power of alpha, then what is the value of alpha they are asking, okay. I hope you remember that question already covered in the classroom, okay. What I'm trying to tell you, in the gate paper one time they asked the problem like this, okay. So there is a flow chart, they have drawn flow chart like this. Here there is a recursive function a of n. Have you remembered this problem friends? There is a conditional operator, okay. There is a conditional operator. Suppose if it is yes, you have to move in this direction. If it is no, you have to move in this direction. Like that they mention flow chart. I hope you remember this problem. Again testing the condition. The condition is true, we can stop. I'm not drawing diagram properly, so please understand this point friends, okay. It is one of the gate question based on this topic. Here they mentioned is a of n by 2. Here also it is a of n by 2. Have you remembered this question friends? In this problem what did they ask? Suppose except recursive call, remaining all functions, okay, whatever is there here, all are taking constant time. accept recursive function, remaining all are taking constant time, order of 1 time. Okay. If the worst case time compressor, this problem is order of n to the power of alpha. If the worst case time compressor for this problem is order of n to the power of alpha, what is the value of alpha? And mention the value of alpha with up to 2 decimal points. So they are saying that the worst case running time for this problem is order of n to the power of alpha. Then you need to find alpha value. Okay. Have you done this problem earlier? If you are not done, can you answer this question now? The worst case time comes, this problem is order of n to the power of alpha. Then what is the value of alpha? And correct that value of alpha with up to 2 decimal points. Yes. So how to solve this type of problem, friends? First, assume that A of n is taking time compressor equals to T of n. Let us assume that the time required for this problem is time required to compute A of n. We are taking it as something like T of n. T of n. Then how much time is required to compute A of n by 2? It will take T of n by 2 time. T of n by 2 time. So it will also take T of n by 2 times. Here also it will take T of n by 2 time. It is T of n by 2 time. Okay. So what I am trying to say, first I am defining, let the time required for A of n is equal to T of n. T of n is equals to time required or time complexity. So time required for computing A of n. Right? A of n. Since they are focusing on worst case time complexity, in this flow chart, worst case will occur only if I start from here, right? If I start from here and if I move towards right direction and moving downward direction like this. Okay, it will take more number of iterations, right, friends? Okay, it will take more number of iterations in this path, therefore it is taking worst case time complexity. Therefore worst case time complexity T of n is equals to so starting from T of n is equals to, see how many times you are taking 1, 2, 3, 4. Actually, sorry for the mistake. Actually, here it is also A of n by 2. Please excuse me, because we are calling the A of n with the starting value. So 1, 2, 3, 4. And actually, here one more A of n by 2 is in the gate paper. Whatever it may be. Suppose if they ask the same question, okay, if they ask same question, it is A of n by 2. We start with A of n. I wanted exact gate question, friends. Okay, sorry for the mistake, but concept remains same only. So here we are having start, right, friends? So it is a time. It is. Let me write properly. Right. So the following algorithm is computing recursive function A of n. The following algorithm is computing recursive function A of n. Then what is the worst case time compressor for computing this problem? Here it is taking T of n by 2. Clear, friends? Okay. Therefore, the time required to compute A of n is equal to T of n. Then how many times T of n by 2 is there? 1, 2, 3, 4, 5. Therefore, you can take it is 5 times of T of n by 2. Remaining time we are taking constant time. The constant time means we can make it as 1, theta of 1. Right, friends? Okay. Now apply master theorem. By using master theorem, A is equals to 5 and B is equals to 2, K equals to 0 and P equals to 0. P equal to 0. Verify, is A greater than b to the power of K? Yes, 5 greater than 2 power 0, which is true. So it belongs to case number 1 of master theorem. So case number 1 of master theorem. Therefore, T of n is equals to theta of n to the power of log 5 base 2, which equals to theta of n to the power of log 5 base 2 means we can write 2.32. Once it is satisfied for theta, theta is nothing but it is also satisfied for big 1 omega. Therefore, we can also say it is order of n to the power of 2.32. But they provide this value equal to order of n to the power of alpha. Now compare alpha value. Alpha value is equals to 2.32. Alpha value is equal to 2.32, friends. Okay, this is the way we need to process the problem. Here the provided flowchart is, the following flowchart is computing a recursive function a of n. The following flowchart is computing a recursive function a of n. To compute a of n, they are starting, and every time it is splitting by half, a of n by 2, a of n by 2, a of n by 2, like this. Okay, in the beginning I have written it is a of n, right? That is not correct. A of n by 2, a of n by 2, like this. Okay, is it clear, everybody, please? So all these cases are useful for understanding merge sort and quicksort algorithm concepts. Okay, next. Sometimes there are some situations where we can come across master theorem in this format. T of n is equals to T of n by 4 plus T of 3n by 4 plus theta of n in this format. Okay, or else T of n is equals to T of n by 3 plus T of 2n by 3 plus something like theta of n. We want to answer this type of questions also, friends. Okay, generally these problems can be addressed by using recursion tree approach. But here it is a revision class. I'll explain by using shortcut method. You remember this shortcut method? Suppose if T of n is equals to T of alpha into n plus T of 1 minus alpha into n plus theta of n format, where 0 less than alpha less than 1, 0 less than alpha less than 1. In that case, the minimum time required for this one denoted by omega of n log n base 1 by alpha less than or equal to T of n less than or equal to, maximum time required for this one is order of n log n 1 by 1 minus alpha. That is a formula, friends. Okay, now compare this problem with the first problem. Suppose if I consider problem number 1 and problem number 2. So in the first problem, what is the value of alpha? Here alpha is equals to, see, alpha, right, alpha into n, alpha value equal to 1 by 4, friends. Okay, so therefore alpha is equals to 1 by 4. Clearly 1 by 4 lies between 0 and 1. 0 and 1. So hence the answer for this question is minimum time is equals to n log n 1 by alpha, n log n 1 by alpha. Since alpha is equals to 1 by 4, so 1 by alpha is nothing but 1 by 1 by 4, that equal to 4, less than or equal to T of n less than or equal to big O of n log n big O of n log n 1 by 1 minus alpha. But what about alpha? Alpha equal to 1 by 4, right? So 1 by 1 minus 1 by 4, that is 4 minus 1. We can take 3, we can say it is 4 by 3. So which equals to 4 by 3. That is the answer for the first question. Okay, minimum time is equal to n log n base 4 and maximum equal to order of n log n base 4 by 3. And whereas in this case, what is alpha? Here alpha is equals to 1 by 3, right, friends? Alpha equal to 1 by 3. So 1 minus alpha means 2 by 3. 1 minus alpha means 2 by 3. Therefore, minimum time is equals to omega of n log n base 1 by alpha. So that equals to 3, less than or equal to T of n less than or equal to big O of n log n 1 by 1 minus alpha. So 1 by 1 minus 3, 1 by 1 minus alpha, that equals to 3 by 2. So this is a shortcut method you have to use, friends, okay, for finding solution for this type of problems. Do you know where we are using this type of recurrence equation? In quicksort algorithm, if we select a pivot element, if the selected pivot element placed into n by 4th position of the array, then what is the worst case time complexity of quicksort algorithm? In that case, we will get recurrence equation in this format: T of n by 4 left part, T of 3n by 4 right part, and selecting pivot element will take theta of n time by using partitioning algorithm. Okay. Similarly, suppose that the pivot element is placed into n by 3rd smallest element position, then left part is n by 3, right part is 2n by 3, and theta of n is nothing but pivot element. That we will discuss when you are talking about Quicksort algorithm. Apart from that, you can remember one more problem regarding recurrence equation. Let me explain recurrence equations for remaining models also, so that it is easy to understand binary search algorithm, linear search algorithm, friends. Okay, let me explain. If you consider simple loop concepts, by using simple loops, we need to construct recurrence equations, equivalent recurrence equations, and we need to address what is the time complexity for the recurrence equation. The first model which I covered in the class, suppose if I value starting from 1, I less than or equal to n, I plus plus, means I value is incrementing step by step, friends. Okay, if I value is incrementing step by step, then how many steps it will take to reach the target? Obviously n steps will take to reach the target. Therefore the time required for this one is theta of n. Right, you can imagine starting value equal to 1 and target value equal to n and reaching step by step, therefore it is taking theta of n time. So in this problem, another one is, you can also express it as, for I is equals to n, I greater than or equals to 1, I minus minus. Here we say starting from 1 reaching n, it means that, let me explain here. Suppose I value is here, 1 is a starting value and target is n. How we are reaching this target means every time we are incrementing one step. Since every time we are incrementing one step, to reach the target, how many steps will take? N steps, friends. Okay. Second time, what I am trying to say, you are starting from I value starting from n, but where you have to reach? We have to reach 1. This time we are decrementing every time one step. So from I equal to n2, we are moving to n minus 1, right? N minus 1. N minus 1 to we are moving to n minus 2. N minus 2. Like that, we are coming back to starting place, like this. Okay. So starting from 1 to 1 and reaching n is same as starting from n reaching 1. Therefore, it is also taking theta of n time only. Theta of n time. Clear, friends? Okay. Now, what is the equivalent recurrence equation for these two problems? Generally, in the recurrence equations point of view, these two problems recurrence equations. Generally, recurrence equation always in the form of decreasing case, because in order to meet the base condition, value of n compulsory must be decreased. Otherwise, we cannot reach the base condition. Therefore, recurrence equation I am writing for second one. Okay, the recurrence equation I am writing for second one, that is T of n is equals to T of how much value you are decrementing every time? You are decrementing 1. Therefore, T of n minus 1 plus, because it is starting from n, right? It is starting from n. Therefore, initially it is starting from n. Every time it is decremented by 1. So, therefore, T of n minus 1 plus 1. Okay, T of n minus 1 plus 1. What is this 1? This 1 indicates that first iteration. Okay, or you can say number of function calls. When n is equals to n, how many function call means 1 function call. After calling one time, input value reduced to T of n minus 1. Clear, friends? Okay, means you can imagine algorithm like this: int f of int n. If n value equals to 0 or if n value equals to 1, we can stop the process, that is written. Otherwise, else written f of n minus 1 like this. Okay, your algorithm may be looking like this. In that case, the time required for executing this algorithm, we are defining it as T of n. T of n. Then how much time it is required for f of n minus 1 means, if f of n takes T of n, f of n minus 1 will take T of n minus 1. Right? Therefore, we can write recurrence equation T of n is equals to with this input n I am calling one time. So with this given input n I am calling one time. With that one time I am entering the function body. If it is meeting the base condition, we can stop the process. So I can say one function call if n value is equals to 1, right? If n value equal to 1, only one function call. Suppose if n value is greater than 1, if n value is greater than 1, so with this input n, we enter into function body one time. That's why I'm calling it as one time. After one time, input value reduced to n minus 1, right? If input value reduced to n minus 1, how many functional will take? T of n minus 1. Therefore, it will take T of n minus 1. So that's what I written here. 1 plus T of n minus 1. Okay, if you want, I can write first 1. 1 plus T of n minus 1. This is the equivalent recurrence equation for the first model, friends. General recurrence equation we are writing in the form of decreasing form, starting from n and reaching up to base condition. Clear, friends? Okay, the first model in recurrence equation. I hope it is clear, everybody. Second model, suppose for I is equals to 1, I less than or equal to n, but every time I am incrementing 2 steps at a time. Earlier it is 1 step, this time I am taking every time 2 steps. And if every time if I am taking 2 steps, it is taking arithmetic progression. Arithmetic progression. In arithmetic progression, you can apply nth term formula. Nth term formula equals to a plus n minus 1 into d. Therefore, here if we start I is equals to 1, and if you want to reach n, it is incrementing 2 steps at a time. 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7, and so on. It is incrementing, right? Okay. I don't know which term it is equals to n. Therefore, I am assuming that it is kth term. It is called kth term. So we can say it is first term, it is second term, third term, it is fourth term. Like that, we are continuing up to kth term. Now, kth term you are taking it is n. Now, write the formula for kth term of arithmetic progression. The kth term formula for arithmetic progression Tk is equal to a plus k minus 1 into d. So, here a is equals to 1, k minus 1 into d. What is the common difference, friends? Common difference is 2. This Tk is equals to n, right? From this, you need to find what is the value of k. Simplify it. So, which is equals to 2k minus 2, that equal k is equals to n plus 1 by 2. Means n plus 1 by 2 steps it will take to reach the target. Based on the input value, generally it is taking floor of n plus 1 by 2 steps. Okay, floor of n plus 1 by 2 steps. Therefore, the time required for this one is equal to theta of n by 2. I want to keep n by 2 as it is only, okay, because if I write theta of n plus 1 by 2, 1 is a constant, I am ignoring it. I am writing theta of n by 2. Keep it is theta of n by 2 only. You know that theta of n by 2, again it is theta of n only, but most of the time I am keeping theta of n by 2. The reason I will explain little later, okay. The reason I will explain little later, but as of now you can keep it as theta of n by 2. Don't write theta of n, friends, okay. The reason why I am writing theta of n by 2 means, suppose if I take the same problem for I is equals to 1, I less than or equal to n, I is equals to I plus m model, I plus m, where m is a constant, okay. M is a constant where m value lies between 0 less than m less than n. In that case, what happens? See, if it is constant is 2, we are taking n plus 1 by 2, n plus 1 by 2. If you apply same procedure, we will get k value is equals to n plus m minus 1 by m under floor, n plus m minus 1 by m under floor, okay. Because here first term is, what is first term? First term is 1 only, common difference is m. Therefore, if I substitute a equal to 1, k minus 1 into m, mk minus m, am I going fast? No, right? Because we are having exam in another 10 days only, right, friends? Okay, I need to rush like this only. Say mk minus m plus 1. From this, you have to find k value. Clear? K value. So, therefore, if you find k value, it becomes n plus m minus 1 by m. But you already mentioned that m value is smaller than n. So, therefore, n is dominating m minus 1. So, we can make it as floor of n by m. I cannot remove m value in the denominator, because if m value increases, automatically n by m value decreases. That's why I had to give importance for the denominator also. It is n by m. right friends, okay. So if it is n by m, obviously it is n by 2, that is the reason I kept 2 as it is only, okay. Right, in these two models, okay, we can also write it as starting from I value starting from n, as long as I value greater than or equals to 1, I can subtract some constant value m like this, constant value. Just observe this model, starting from 1, reaching n, every step by adding m is same as starting from n, reaching 1 by subtracting m every time. Am I right or wrong? The way how I explained here, same thing. Starting from 1, reaching n by incrementing I 1 by 1 is same as starting from n, reaching 1, decrementing one step at a time. Right friends, okay. So therefore, it is same as I equal to n, I greater than or equal to 1 and I equal to I minus m. As I mentioned, the distance between from my home to your home is same as the distance between your home to my home, right? In the same way it is also, okay. Is it clear friends, okay? Right. In these three cases, when you are talking about recurrence equation we are writing only if value of I is decrementing, right? Therefore, here I can write recurrence equation, that is T of n is equals to, first let me write recurrence equation for the simple part, okay, simple part, okay. Give me 1 minute time friends, okay. Here we are writing for I is equals to n, I greater than or equals to 1, I equals to I minus 2, I minus 2. So then the recurrence equation for this one is T of n is equals to 1. What is the purpose of 1? First function call, okay. It is a first function call, therefore I am taking it as 1. After first function call means your algorithm is looking like this, int f of int n, if n is equals to 1, control return to operating system. If this condition fail, then return to f of n minus 2, f of n minus 2. Clear friends, f of n minus 2. In that case, the time required for computing f of n, I am taking it as T of n. T of n. You know, recursive algorithm time complexity always bounded by the total number of function calls, right? Total number of function calls. Therefore, f of n takes how many function calls? T of n function calls. That's why I'm taking T of n. With the input n, I'm entering the function body first time. That's why I'm counting it as one call. With the input n, I'm entering the function body first time. That's why I'm calling it first function call. If it is meeting the base condition, you can stop the process. In the worst case, we had assumed that it is not meeting the base condition, then we had entered into else part. Then f of n takes T of n, then f of n minus 2 takes T of n minus 2. Am I right? So therefore, it is T of n minus 2. Just to compare these two friends, you are starting from n, reaching 1, and every time you are subtracting 2. You are starting from n, reaching 1 because base condition is 1, and every time you are subtracting 2. Are these two are same or not? Yes. Therefore, the equivalent recurrence equation is 1. Both the cases time complexity is theta of, yes, just now explained, right? If it is I minus 2 means you are take it as n by 2. So theta of n by 2. Is it clear? Theta of n by 2. This is the equivalent recurrence algorithm. Then suppose if I take another case like for I is equals to n, I greater than or equals to 1, I is equals to I minus m. Right friends, I minus m, which is same as this model, right? Which is same as this model. So 1 plus T of n minus m, 1 plus T of n minus m. Then what is the answer for this one? That equal theta of n by m, theta of n by m. So it is second model which I explained in simple loops. First model completed, second model completed friends, okay. If I extend this problem for third model, model number 3. for I is equals to 1, I less than or equals to n, I is equals to I star 2. Means you are multiplying with 2. Every time you are multiplying with 2. Clear, friends? Okay. If every time you are multiplying with 2, it is following geometry progression. Geometry progression. It is having format like this. I value is starting from 1, multiplying 2, 4, 8, and so on. It reaching target is n. But we don't know which step it is reaching the target. That's why I'm assuming that it is a kth term. It is a kth term. Then by assuming it is first term, it is second term, right, friends? Okay. Up to so on, we are continuing kth term. What is the kth term formula in geometry progression? Tk is equals to a into r to the power of k minus 1, right? Where kth term is equal to n is equals to a means 1, r to the power of k minus 1, that is equal to the power of k minus 1. Now simplify for k value, friends. Okay. By simplifying for k value, k minus 1 is equals to, bring 2 this side, it is acting as log n base 2. Log n base 2. From this we can find k is equals to 1 plus log n base 2. Means this loop is running 1 plus log n base 2 times. Okay. If you want exact number of times it is running, you can apply floor value, floor of 1 plus log n base 2. Therefore, the answer for this one is floor of log n base 2. This is same as, friends, okay, this is same as, we can write for I is equals to n, I greater than or equal to n, I is equals to I by 2. Am I right? No, sorry for the mistake. You are starting from 1, reaching n by multiplying 2. It is same as starting from n, dividing with 2 and reaching 1. Both are equivalent or not? Yes. That's why both are taking same time complexity, 1 plus log n base 2. Repeating once again, start from 1, reach n by multiplying every time I value with 2. Is same as start from n, reach base value by dividing I by 2. Both are equivalent. Therefore, it is also taking 1 plus log n base 2, friends. Okay. It is also taking 1 plus log n base 2, that is theta of 1 plus log n base 2. I am not writing 1 here because 1 is a constant, so I can write it as log n base 2. Then you know that recurrence equation is possible only if n value get decremented. So first case n value is not decremented, means I value is not decremented, I value is increasing, whereas second case I value is decrementing. Therefore, the recurrence equation in this format, T of n is equals to 1 plus T of n by 2 model. T of n by 2 model. Okay. Actually, our algorithm may be looking like this. See, our algorithm may be looking like this: int f int n. If n is equals to 1, simply return. Otherwise, else, if this condition is false, you can return f of n by 2 like this. F of n by 2. Clear, friends? Okay. So, in order to address this type of time complexities, we have to assume that f of n takes how many times? T of n. T of n. Therefore, T of n is equals to, with this input n we are entering to function body one time, that's why I count it is one time, one function call. Afterwards, input value reduced to half, therefore it is taking T of n by 2 time, right, friends? Okay. So, therefore, T of n equal to, after first call, input value reduced to n by 2, therefore T of n by 2. This is equivalent recursive algorithm for the given recurrence equation. Then what is the answer for this question? Same, that is theta of log n base 2. Theta of log n base 2. This is the recurrence equation for binary search algorithm, because I am going to discuss binary search sorting algorithms, right? So, without having knowledge about this recurrence equation, it is very difficult to answer them. So, that is the reason I am introducing recurrence equations first. Okay. So, T of n equal 1 plus T of n by 2, which equal theta of log n base 2. I can say immediately it is a binary search recurrence equation. Binary search recurrence equation. Okay. Next, let me extend this topic, friends. Okay. Here I explain with a constant. See the pattern how I am taking. Here constant value, here constant, afterwards variable, here constant, again I am taking variable now. Okay. It may be same as for I is equals to 1, I less than or equal to n, I is equals to I star m. Or else phi or I is equals to n, I greater than 0 or I greater than or equal to 1, I is equals to I by m. See, starting from 1 reaching n by multiplying with m is same as starting from n dividing every time by I by m and reaching 1. These two are equivalent. These two are equivalent. Clear, friends? Okay. If you are dividing, if you are multiplying with 2, we are getting answer is log n base 2. Log n base 2. If you multiply with 2, you are getting log n base 2. If you multiply with m, you will get log n base m. Right, friends? Okay. You will get time complexity equal to theta of log n base m. But you know, recurrence equation possible only for decreasing functions. Therefore, here I can write equivalence recurrence equation. T of n by m. Is it clear, friends? Okay. So these two comes under model number 3. Model number 3. Right. Next model. Suppose if we start from I is equals to n, I greater than 0, I is equals to square root of I. I is equal to square root of I. So whenever it is square root of I, in the last year gate paper also this problem they made mistake in the question paper, friends. So I cannot say they made mistake. Okay. Generally they have to give this value equals to I greater than or equal to 2. Then only base condition will be satisfied. Okay. So I equal to n, I greater than or equal to I equal to square root of I model. Means every time input value reduced to square root. In that case, just look at here, friends. I value is starting from where? It is starting from n. Every time it is having square root, means the first iteration n, first iteration is n. After first iteration is completed, second iteration, when it comes to second iteration, it is square root of I. Square root of means square root of n. So square root of n we can write n to the power of 1 by 2. Right? Next, if I go to third iteration, it is again taking square root 2 times. Just observe, first iteration n, second iteration square root of n. That's why we are making it as equals to n to the power of 1 by 2. Third iteration square root of n, which equal n to the power of 1 by 4. 4 we can write n to the power of 1 by 2 square. Right, friends? If it is one more iteration, I can take square root n to the power of 1 by 8. 1 by 8 I can write n to the power of 1 by 2 power 3. Right, friends? Okay. So therefore, by placing these values, it is n to the power of 1 by 2 square. If I go to one more iteration, n to the power of 1 by 2 cube, correct? But how long I can continue this process? Up to kth term. Because every problem we are doing up to kth term. If it is kth term, n to the power of 1 by 2 power k minus 1. Is it correct? Yes, it is correct. Because if it is fourth term, I am writing n by 2 power 3. 2 power 3. Fourth term is 2 power 3. Third term is 2 power 2. And kth term is 1 by 2 power k minus 1. After computing up to kth term, assume that this kth term value is equal to base condition of this problem. Who is the base condition? Base condition is equal to 2. Right? Base condition equal to 2. Therefore, you have to equate this value with 2, friends. Okay. Let n to the power of 1 by 2 power k minus 1 is equals to 2, you can make it. From this, you are supposed to find what is k value. So therefore, 1 upon 2 power k minus 1 is equals to log 2 base n. Log 2 base n. I can take reverse reciprocal of this value. Okay. By taking reciprocal 2 power k minus 1 is equals to log n base 2. Because when you turn this one, base means 1 by 2 power k minus 1, if you make it as 2 power k minus 1, here base becomes value, value becomes base. From this we can say k minus 1 is equals to log base 2 of log n base 2. From this I can find k value also. K is equals to 1 plus log base 2 of log n base 2. Is it clear, friends? Okay. So therefore, this problem time complexity is equals to 1 plus log base 2 of log n base 2. So just have a look on this. Immediately I will remove this part. Okay, let me zoom out. I hope you are understood, right? Okay. So therefore, if it is in the case, it is taking theta of log base 2 of log n base 2, theta of log base 2 log n base 2. So this equation we can also write, sorry, this model we can also write it as for I is equals to 2. Here it is starting from n reaching 2, starting from n reaching 2. Now I am writing in the reverse. Starting from 2, it has to reach 2. Sorry, starting from 2, it has to reach n. I less than or equal to n. I is equals to I square. Means both are same only. The distance from my home to your home is same as the distance between your home to my home only. Okay. So therefore, I equal to 2, I less than or equal to n, I equal to I square. So in this problem also it is taking theta of log base 2 of log n base 2. Then what is the recurrence equation for this? You know, recurrence equation only possible for the decreasing function. So it is a decreasing function here, right? Okay. So therefore, t of n is equals to 1 plus t of square root of n. This is a equivalent recurrence equation. Right, friends? This question asked multiple times in the gate paper, multiple times. Maybe in your exam they will ask question like int do int n. If n value less than or equal to 2, return, else return do of square root of n, like this. Okay, they'll ask question like that, do of square root of n. So in this case, what is the time complex of this problem means? Just assume the time required for evaluating this problem, you can consider t of n, right? Therefore, t of n, you know, time complexity always proportional to total number of function calls, So with this input n, we enter into function body one time, right friends, one time. That's why with this input n, we are counting one time. If it is meeting base condition, you can stop the process. If it is not meeting the base condition, I had entered into else part. In the else part, it is do of square root of n. Do of square root of n will take t of square root of n. Therefore, it is t of square root of n. So that is equivalent recurrence equation, friends. Okay. Next, afterwards, we can also write it as for I is equals to first constant factor we have taken. Now we can take some variable also. Okay. For example, if I start from for I is equals to n, I greater than or equals to b, means in the place of 2 I am writing b, I greater than or equal to b, and every time I is equals to eighth root of I. Clear, friends? Eighth root of I. In this case, means in the place of square root of I am writing eighth root of I. In this case, the time complexity is theta of log, please understand this base 2, you know how we are getting first base 2? First base 2 is square root of 2, 1 by 2. 1 by 2 means the 2 value is the first base, whereas second base value is equals to this value, second base value. So therefore, first base value equal log A, second base value must be B, theta of log base A of log n base B. If you have any doubt, you can continue. See, it is I to the power of, let me explain it quickly. So first I value, what is the value of I, friends? N. Afterwards it is n to the power of 1 by a, because I to the power of 1 by a means n to the power of 1 by a, correct? Next it is n to the power of 1 by a square. Like that we can continue up to kth iteration, n to the power of 1 by a to the power of k minus 1. Now we are making this value equal to base condition. Clear, friends? Okay. What is the base condition? Base condition equal to b here. Therefore, assume it is the base condition, n to the power of 1 by a to the power of k minus 1 is equals to base condition. Base condition equal to b here, right? We can write 1 by a to the power of k minus 1 is equals to log b base n. By taking reciprocal, a power k minus 1 is equals to log n base b. From this k minus 1 is equals to log base a of log n base b. So that's what I mentioned. First who is coming? Log base a is coming, followed by log base b. Then what about another way of writing this problem? For I is equals to b, we can write I less than or equal to n, I is equals to I to the power of a, which is both are equivalent. These two are equivalent. Okay. Then equivalent recurrence equation for this. Recurrence equation we can write only reducing functions. Reducing functions. Therefore, T of n is equals to 1 plus T of eighth root of n. That's all. Eighth root of n. Clear, friends? Eighth root of n. And time complexity is theta of log base a of log n base b. Log n base b. So these two are equivalent. That's all, friends. Okay. If you could understand these models, your time complexity concept is very simple. Yes, it is I plus m. I equal to n, I greater than or equal to n, I plus m. They are adding plus, right? Correct. I plus m. Now what we will do, by using these problems, how I am going to generate another recurrence equation model. See, just observe. I want to zoom out, friends. Okay. Suppose if they provide recurrence equation like this, on the time complexity, space complexity for recurrence equations. Let me draw the lines, friends, so that it is easy for you to understand. Yeah. So could you please listen? Suppose I think it is not visible, right? Yeah. You know that T of n equal 1 plus T of n minus 1, time compressed equal to theta of n. Suppose in the exam if they ask question like this, T of n is equals to T of n is equals to 1 plus 2 times of T of n minus 1. If they ask T of n equal 1 plus 2 times of T of n minus 1, what you will do, this 1 plus 2 times of T of n minus 1, you can split like this, 1 plus T of n minus 1 plus T of n minus 1. You can split like this. Clear, friends? Okay. I'll explain this problem, only one problem within 1 minute. Afterwards, I'll explain remaining problems in a shortcut manner. Try to understand, okay? If they provide recurrence equation, T of n is equals to 1, if n is equals to 1, and it is 1 plus 2 times of T of n minus 1, if n value is greater than 1, then how to solve this type of recurrence equations? You can apply recursion tree approach also. You can apply recursion tree approach. So by using recursion tree approach, how we are going to write? This is T of n is equals to means you can imagine T of n, you are calling T of n f of n. It is splitting as f of n minus 1 and f of n minus 1 and adding this T of n results. Okay, T of n results. Okay, so therefore, for this problem, the algorithm may be looking like this: int f of int n. If n is equals to 1, return, because you're taking some values here. If you want, you can return some value 1, return 1, else return f of n minus 1 plus f of n minus 1. So this is a model we need to consider, friends. Okay, this is a model you have to consider. Then how we are going to execute this problem? Suppose the time required for computing this problem is T of n. You can take it as T of n. Right? With this input, we enter into function body one time. That's why you have to count it as 1. You have to count it as 1. After calling one function call, that one function call may be equal to base condition also. If it is a base condition, we can stop it. If it is a base condition, you can stop it. If it is not satisfying base condition, after one function call, then control enter into else part. In the else part, left part will take f of n minus 1. Left part will take f of n minus 1. Right? Left part will take f of n minus 1. If f of n takes t of n, f of n minus 1 will take t of n minus 1. This f of n minus 1 will take t of n minus 1. Is it correct? So therefore, with the input n, we are calling first time. After first time, left part is taking t of n minus 1, right part is taking t of n minus 1. Clear, friends? Okay. And if you want to solve this recurrence equation, generally we are solving like this: f of n value is splitting into f of n minus 1 and then f of n minus 1. Correct? And afterwards we are adding these two results. And again f of n minus 1 is splitting as f of n minus 2 and f of n minus 2. And we are adding these two results. It is splitting as f of n minus 2 and then f of n minus 2 and add these two results here. So this is the way we discuss in the classroom, right? So how many function calls are there? How to compute function calls? At this level, we have only one function call. Correct, friends? One function call. At this level, we are having two function calls. And at this level, we are having 4 function calls. 4. It means it is growing exponentially. So 1 we can write 2 power 0, 2 we can write 2 power 1, 4 we can write 2 square, right? 2 square. Like that we can continue. For example, it is level 1, level 2, level 3 like this, okay? We are continuing up to, how long we are continuing means we are continuing up to, we can call it a first iteration, it is a second iteration, it is a third iteration. How long we need to continue up to? Kth iteration. If it is third iteration, we are subtracting 2. If it is second iteration, we are subtracting 1. If it is kth iteration, we are subtracting k minus 1. right? F of n minus k minus 1. Here also we are doing same process. So if it is third iteration 2 square, function calls. If it is second iteration 2 power 1, function calls. If it is kth iteration, how many function calls are there in kth iteration? In kth iteration, we are having 2 power k minus 1 function calls, right friends? Okay, because time complexity always depends on the total number of function calls. It is regarding function calls. Okay, number of function calls. It is iteration number. First iteration, second iteration, third iteration up to kth iteration. But why did you stop at kth iteration? We are assuming it is in the base condition this problem. The base condition value for this problem is 1. Therefore, you have to make this value equal to 1, friends. You have to make this value equal to 1. Let n minus of k minus 1 is equal to 1. From this, we can say k is equals to n, because 1 get cancelled, you get k equal to n. Then the total number of function call, if I sum up this total value, you will get total number of function calls. The total number of function calls is equals to 2 power 0 plus 2 power 1 plus 2 power 2 up to so on 2 power k minus 1. These many function calls are there. It is following geometry progression. It is following geometry progression. A into r to the power of k, because k terms are there, right friends? K terms, okay? R to the power of k minus 1 by r minus 1, which equal 2 power k minus 1. But what is k? K is equals to n. Therefore, you can say it is 2 power n minus 1. 2 power n minus 1. Therefore, time complexity equals to theta of 2 power n by ignoring constant. Now, I am introducing most important point which is really useful for solving problem very quickly within fraction of seconds. Okay, within fraction of seconds. If everybody is an active, simply type A in the chat box. A means active. Okay, I am going to introduce most important point. Right. Thank for your quick response. Just observe, friends. In the exam, actually time is very important for you. Therefore, you need to answer question within fraction of seconds sometimes. Especially algorithm subject point of it is very easy. You understand this problem, t of n equal to 1 plus 2 times of t of n minus 1, right? In the exam, what we'll do, actually we are doing process only one direction, correct? Only one direction, and we are finding k value. It is same as simple loop concept. In the simple loop concept, f of n minus 1, f of n minus 2, up to so on f of n minus k minus 1, correct? I hope you understand what I'm trying to say. So you have to compute only one direction. One direction means this problem, what you will do, they provided t of n is equals to 1 plus 2 times of t of n minus 1, right? My suggestion is you can write like this, 1 plus t of n minus 1 plus t of n minus 1. Okay. Anyway, you are finding values only one direction in order to get the value of k. It means that you are solving this problem. Only this problem you are solving. But this problem already solved earlier, right? We already solved earlier. Okay. So after solving this problem, earlier case, just go back to previous one. See here, friends. We already solved it is 1 plus t of n minus 1. If you understood 1 plus t of n minus 1 value equal to theta of n, now come back to this question. We know that this part obviously it is taking theta of n. Then this total part will take time complexity is equal to theta of, how many times you are splitting this function? 2 times you are splitting. That's why theta of 2 times you are splitting, and 1 time split 1 plus t of n minus 1 having value equal to n. Simply write that answer here. That's all, friends. Okay, since it is splitting 2 times, t of n minus 1 plus t of n minus 1, 2 times it is splitting, therefore you are taking theta of 2. And what is the exponent value means this value, that equal theta of n. Simple logic you can remember. In this case, what is space complexity? You know, space complexity always depth of the recursive stack. It is nothing but depth of the recursion tree. So in that case, depth of the recursion tree means again it is simple loop only, right? This is a depth which is equals to theta of n. If time complexity is theta of 2 power n, space complexity must be theta of n. Is it clear, friends? Suppose in the exam if they ask question, T of n is equals to 1 plus T of n minus 1 plus T of n minus 1 plus T of n minus 1. 3 times they ask. Then what is the time complexity for this problem? So what we will do, you know time complexity for this problem, right? That equal how much? Theta of n. That is in fact space complexity for this problem also. Now how many times you are splitting here? 1, 2, right? 3 means 3 ways it is splitting. 3 ways splitting. So therefore, since it is splitting 3 ways, 3 functions. So theta of, first you can write 3 whole to the power of n, theta of 3 power n. That is the time complexity for this problem. And space complexity remains same, theta of n. So once you understand this logic, see how quickly we are answering this question now. Kindly look at here, friends. 1 plus 2 times of T of n minus 1. You know that this value answer is 1 plus T of n minus 1, answer is theta of n. Therefore, its time complexity is theta of 2 to the power of the time required for 1 plus T of n minus 1, that is n. Space complexity theta of n. This is the value space complexity to consider. Okay. So next one, it is 1 plus T of n minus 2, right? T of n minus 2. Suppose if they ask question, T of n is equals to 1 plus 2 times of T of n minus 2. 2 times of T of n minus 2. Then how you are going to express? 2 times of T of n minus 2 we can express it as 1 plus T of n minus 2 plus T of n minus 2. Correct, friends? T of n minus 2 plus T of n minus 2. And you already evaluated this problem answer, right? What is the answer for this one? Theta of n by 2. Theta of n by 2. If it is theta of n by 2, if this value is theta of n by 2, here this value equal to theta of, since we are splitting 2 times here, 2 times, this indicate 2 times, okay? 2 times. Therefore, theta of 2 power n by 2, n by 2. Theta of 2 power n by 2. I hope you understood why I am keeping n by 2 as it is now. Because n by 2, if I make it as theta of n, this value becomes theta of 2 power n. There is a huge difference between theta of 2 power n and 2 power n by 2. That is the reason keep it is theta of n by 2 as it is only. Right, friends? Okay. Now, what about this one? Suppose if you take constant value. Suppose the recurrence equation is T of n is equals to 1 plus 2 times of T of n minus m. If you are having recurrence equation like this, we already evaluate 1 plus T of n minus m as theta of n by m. Therefore, it is taking theta of 2 power n by m, where space complexity is theta of n by 2 here and theta of n by m. Space complexity for whom? For this problem, right? Next one, it is 1 plus T of n by 2. If you have T of n is equals to 1 plus 2 times of T of n by 2. Directly I am writing without wasting time. If write 2 times, we can write theta of, here if we are having 2 value, friends, okay, 2, we can write theta of 2 power. For one time, of how much time it is taking? 1 plus T of n by 2, how much time it is taking? Log n base 2. 1 plus T of n by 2 will take log n base 2. Therefore, theta of 2 power log n base 2. But what is 2 power log n base 2? That equal theta of n. Correct? 2 to the power of log n base 2 means theta of n. Let me write small letters. Okay. Theta of 2 power log n base 2, which is nothing but theta of n. That's it, friends. Okay. We can also extend for n by m. N by m. It is T of n is equals to 1 plus 2 times of T of n by m. 1 plus 2 times of T of n by m. Then answer for this question is theta of 2 power log n base m. We can keep it as it is only. Okay. So what is space complexity here? Space complexity is theta of n by 2. No, theta of log n base 2 and a space complexity theta of log n base m. Next, last model, friends. Okay, if it is 1 plus t of square root of n, so 1 plus t of n is equals to 1 plus 2 times of t of square root of n. This question asked one time in the gate paper also. Okay, one time they asked this question in the gate paper. So you know that 1 plus t of root n equal how much? 1 plus t of root n equal theta of log base 2 of log n base 2. Therefore, 2 times they are asking theta of 2 power log base 2 of log n base 2. Log base 2 of log n base 2. It is a power log base a log n base b. Therefore, it is same as, which is equivalent to theta of log n base 2. Am I right or not? Because a power log base a b. What I am trying to say, a to the power of log b to the base a. What is value, friends? That value equal b, right? B. Who is b in this case? Log n base 2. That's what is theta of log n base 2. Okay. So next one. What is space complexity? Space complexity is theta of log base 2 of log n base 2. Next one. If I take eighth root of value, so for this problem t of n is equals to, this question asks one of the gate problem, friends. So 2 times of t of eighth root of n they are asking. Then theta of 2 power log base a log n base b. Space complexity theta of log base a of log n base b. That's all. So that is importance of this table, friend. I really love to teach this topic for the students because we are reducing their time, valuable time, and they're able to answer many questions within a short period of time. Yes, we cover time complexity concepts. Okay, so time complexity over, master theorem concept is over, simple loop, of course, nested loop also same, and then recursive algorithms also completed. Recursive algorithms also completed. Right, friends. Okay. Next, we'll discuss searching algorithms, which is useful for DA students as well as CSE students. One is linear search, another one is binary search, friends. Okay. So, what type of questions you can expect from this topic? Linear search and binary search. So, we'll discuss the linear search and binary search concept now. Okay. The next topic which we are going to discuss, that is searching algorithm. So, let us consider an array having elements like 1, 2, 3, 4. Assume that array contains 14 elements, friends. Okay, 14 elements. Here having elements, let me write elements here in the random order. I'm writing elements. Okay, so suppose it may be 25, 40, 80, 60, 35. Suppose there is an array which contains exactly 14 elements in this case, 14 elements. Now I want to apply searching algorithm for searching a particular key element, friends. Okay, first we'll discuss linear search algorithm. Linear search. Look at here, friends. So linear search point of view, there are 3 types of time complexity we need to discuss. Like, what is the best case time complexity, what is the worst case time complexity, what is the average case time complexity. Clear? So when it comes to best case is nothing but minimum amount of time taken by the algorithm. Minimum amount of time taken by the algorithm to produce output is called best case of the algorithm. Clear? In this case, for example, from this array, if you want to search x is equals to 25, search x equal 25. So searching x is equal 25 will take only one comparison. Therefore, search x equal 25 will take number of comparisons are 1. 1 means omega of 1. This is called best case, friends. Okay, best case time complexity. And if you take worst case time complexity, search x is equals to 26. X equal 26. Then your search algorithm will start from first index. Okay. See, remember, whenever any searching algorithm, if we found key, then it will return the index of that element. Okay. What is the index of 25 here? Index of 25 is 1. So it will return 1. Index of the matching key is 1. Therefore, it will return 1. Clear, friends? Okay. Next, if you want to search x equal 26, search process starting from first index value is 25. I'm expecting 26, which is not matching. Then we'll continue the search process till we find that element. In the worst case, that element is going to find, actually here I have taken two 26 values. Okay, let me, please excuse me. Let me change this value, friends. Okay, let it be 36. I'm keeping this 36. Okay, so therefore, if you want to search x equal 26, in the worst case, I had to traverse the complete array. Therefore, it is taking time complexity equals to order of n. Means total number of elements in the array is equal to n. Therefore, you have to scan complete array with n comparisons. That's what is taking order of n. Clear? The next one, average case time complexity. Average case time complexity, we are using one formula, summation I runs from 1 to n pi into ti. So this is the formula for finding average case time complexity. What is the meaning of pi? Probability of occurrence of ith event. What is ti? What is ti? Time required to find ith event. For example, here we are having 14 elements, right? 14 elements. If I expand this one, we can write like this: P1 into T1 plus P2 into T2 plus and so on, Pn into Tn. Suppose P1 is a probability of occurrence of event 1. What is that event 1? Searching first index element. Similarly, P2 is nothing but probability of occurrence of second event. What is second event? Means searching second index element. Okay. So therefore, if I analyze like that, the probability for occurrence of first index, the probability of occurrence of first index. Total how many elements are there here? 14. In general, if I assume that n elements, then what is the probability of occurrence of first index? Means only probability is 1 upon n. Because out of n indexes, how many indexes are having 1? Only one index is having 1. Therefore, the searching key probability of occurrence of first index is 1 by n. But to search first index, how many comparisons are required in linear search or sequence search? Only one comparison is required. That's why the time required for this one is only one comparison. Or maybe you are going to search second index. Then what is the probability of occurrence of second index? Second index, only one index is available, right? Second index how many times appear? Only one time. Since second index appear only one time, therefore probability is equals to 1 by n. So probability is equal to 1 by n. But time to reach that index is equals to 2 comparisons. How many comparisons are required to reach second index? 2 comparisons, right? Like that, if I continue, probability of occurrence of nth index also only one time nth index is there. Therefore, probability is equals to 1 by n. But to reach nth index, how many comparisons are required? N comparisons are required. Because to reach nth index, you have to start from 1, 2, 3 up to so on that for n. Therefore, by taking 1 by n outside, we'll have 1 plus 2 plus 3 plus up to so on n, which equals to 1 upon n into, it is sum of n natural numbers. So sum of n natural numbers we can write it as n into n plus 1 by 2. So n get cancelled, we'll have n plus 1 by 2. In GATE exam paper, one of the previous year GATE question, they ask what is the average number of comparisons are required in sequential search. Average number of comparison. They directly provide this answer, n plus 1 by 2. Clear friends, okay? N plus 1 by 2 comparisons are required in average case of sequential search. When you apply average case is denoted by theta notation, theta of n plus 1 by 2. Theta of n plus 1 by 2. You know, in the asymptotic notation, there is no importance of the constant factors. Therefore, we can reduce it to theta of n. Theta of n. So, therefore, these are three types of time complexities. Best case, worst case, and then average case. Three types of time complexities. Can we construct recurrence equation for linear search? Yes, of course, we can construct. Recurrence equation also we can construct for linear search. So, suppose I am defining T of n like this. T of n is equals to time complexity for searching a key from the array of n elements. From the array of n elements. Time complexity for searching a key from the array of n elements. It means that we are having array. So, this array contains n elements starting from 1, 2, 3, dot n. Clear friends, okay? The total time required for searching a key out of n elements, I am defining it as T of n. T of n. Therefore, T of n is equals to, first to whom you are going to perform comparison? You are going to perform comparison the first element, right? First element. If it is matching, directly you can return that element. You can return index of that element. Therefore, first you are performing comparison the first index. If it is matching, then you can return. So, therefore, in this case, array contains only one element or n is equal to 1, or if it is matching first element, then we can stop the process. Okay, friends, okay. Suppose if array contains n greater than 1, in that case, first you have to perform comparison the first element. So, one comparison is completed. Time comparison means here comparisons, friends, okay. One comparison is completed. It is not matching. If it is matching, it belongs to best case. If it is not matching, then what I have to do? If it is not matching, from the rest of the n minus 1 element, you have to continue the process. Okay. So, rest of the n minus 1 elements you have to continue the process means, because of its recursive behavior, this n minus 1 elements will take T of n minus 1. Correct, friends? Okay. So, total n elements are there. Therefore, T of n value, if n is equals to 1, only one element is there. Therefore, one comparison enough. Therefore, time is equals to 1. If n value greater than 1, first I am performing compare the first element. If it is matching, we can stop the process. That comes under best case. Clear, friends? Okay. If it is not matching, then what you have to do? From the remaining n minus 1 elements, we want to search the element. Therefore, T of n minus 1. T of n minus 1. Okay. So, we can solve this recurrence equation by using the approach. Okay. Like which we discussed earlier. Have you remembered simple loop concepts? Okay. What is the answer for this question? Theta of n. Theta of n means we can say order of n as well as omega of n also. Okay. So, therefore, this value we can write order of n or omega of n also. This is called worst case time complexity. Right? Is linear search is clear, everybody? What are the different values we discuss in linear search? Best case, worst case, average case, and recurrence equation. These are only possible ways of asking questions in linear search. Once you are having idea about sequential search, then we want to discuss binary search algorithm, friends. Okay. What are the key points in binary search algorithm? First, you need to understand which strategy they are applying in binary search. The design strategy is called divide and conquer strategy. Okay. In binary search algorithm, we are using divide and conquer strategy. This question asked in multiple times in match the following. In a match the following question, they ask this question, this topic multiple times. We are using divide and conquer strategy, friends. Okay. And what are the prerequisites for applying binary search? Can we directly apply binary search in every array? No. The prerequisite is array must be sorted in increasing order. Array must be sorted. It is a prerequisite. Then only you can apply binary search algorithm. Therefore, let me take elements in the sorted order. I am taking elements in the sorted order. So, second condition also meeting, right friends, okay. In the binary search algorithm, what it will do, it will compute mid value with the help of low and high index. For example, if I consider low index is 1 and high index is 14, low index is 1, high index is equal to 14, then it is computing mid index by using this formula. Mid index is equals to floor of low plus high by 2. Floor of low plus I by 2. Clear friends. So, by using mid index, it is taking 3 different cases now. The key which you are going to compare is called key. Okay, suppose you are going to compare, you are going to search a key is known as key. This key value you are going to compare the middle element. Middle element. Then there are 3 possibilities. There are 3 possibilities. So, with respect to this key, there are 3 possibilities. Key may be equal to A of mid. Key may be equal to A of mid. Directly it is matching the mid element. If it is directly matching the mid element, simply you can return mid index. Return mid index. Clear friends, okay? If it is matching with the middlemost element, you can return index of the middlemost element. Or else, second case, if key value less than A of mid, means it is not equal to mid, it is less than A of mid. And array is already sorted, therefore your search towards left side of the mid element, right? Left side. Therefore, you can apply recursively binary search in the index starting from low to mid minus 1. Okay, search from low index to mid minus 1 because key value is less than A of mid, right? That is when you have to search towards left side. In the third case, key value may be greater than A of mid. A of mid. In that case, you have to ignore that mid element, then search key value from the index starting from mid plus 1 up to high. We need to continue this procedure. How long we need to continue this procedure? As long as low value less than or equal to high. As long as low value less than or equal to high, we can continue this process. If low index is exceeding high, you can stop the process and it will return minus 1. Okay, it means that if low value greater than high, okay, greater than high, and none of the case is matching, then what it will return? It will return minus 1. Minus 1 indicates that unsuccessful search. Minus 1 indicates that unsuccessful search. If none of the cases is matching, you have written low greater than high. Low greater than high means written minus 1, that equal unsuccessful search. Okay. Let me apply this process for the given problem. So, for the given problem, I am taking low index and high index and also computing mid value by using formula floor of low plus high by 2. This is a formula, friends. Okay. So first low index is equals to 1 and high index is equals to 14. That's I'm writing. Low index is equal to 1, high index is equals to 14. Right? What about mid index? 1 plus 14, 15 by 2, 7.5. Floor of 7.5 means 7th index. Now I want to search element, let it be search x is equals to 151. I want such x equal to 151. So in that case, after finding 7, take a of 7th index. Take a of 7th index. What is a of 7th index? Just look at here, friends. A of 7th index value equals to 58. Now compare key with the middlemost element 58. So your key x is equals to 151. Verify 151 equal to 58. No, it is not satisfying. Means first case fail. First case fail. Verify 151 greater than 58 or not. Yes. Key value greater than a of mid. If key value greater than a of mid, low parameter is changing to mid plus 1. There is no change in high parameter. Therefore, low is equals to mid plus 1. Mid plus 1 means 7 plus 1 that equal to 8. There is no change in high parameter. Right, friends? Okay. Now again compute mid value. 8 plus 14, 22 by 2 that equals to 11. Now compare against 11th element. Compare against 11th index element. So 11th index element is equals to 124. 124, friends. Okay. Now take x and compare with 124. 151 is equals to 124. This condition. Key equal a of mid. No, this condition fail. Key less than a of mid. No, key less than a of mid is not correct. Again, key is greater than a of mid. Therefore, search towards right side. Right side means mid plus 1 to high. So low is equals to mid plus 1. 11 plus 1 that equals to 12. High value is equal to 14. Compute mid value that equal to 13. Now a of 13th is equals to, take 13th index element, that is 142. 151 is compared with 142. 151 is still greater than 142. Therefore, research towards right side of 142. So right side of 142 means that equals to mid plus 1 that equal to 13 plus 4, 114, and here also it is 14. Low value is equal to mid plus 1, high value is 14 only. Then again compute mid value, friends. 14 plus 14, 18 by 28 by 2 that equal to 14. Now take a of 14th element which equal to 151. Now it is 151 is equals to 151. Yes, means it is matching. Key equal to a of mid is matching. Then what you have to do? Return mid. Therefore, it will return mid element. What is mid, friends? Here mid is equals to 14. Return 14. That's all. Return 14. Is it clear? Now suppose same problem, in the place of x equal 151, I want to take x equals to 200. I will show in the yellow color, you will get more clarity. X equal to 200. First it is comparing with 58. 200 is right side of 58. That's your search towards right side. Then x is compared with 124. 200 is greater than 124. Your search towards right side of 124. Then 200 is compared with 142, right side of 142. 200 is compared with 151, right side of 151. In that case, what happened? Next iteration, friends. Next iteration. Low is equals to mid plus 1 comma high. Are you following? If I go to next iteration, low is equals to, low how much? That is mid plus 1. Mid plus 1 means 5 and then 14. Mid value equal how much? See, if low value equal 15 and high value is equals to 14. This condition reached. Low greater than high condition reached. It means a return minus 1. So low greater than high condition is meeting, return minus 1. Therefore, for this problem, low greater than high, then what you have to do? We have to return minus 1. What is the indication of minus 1? Means the key 200 is not found successfully. The key 200 is not found successfully. Next. Then how to write recurrence equation for this problem? Just observe recurrence equation. Suppose let T of n is equals to time complexity for searching key out of n elements. Searching key out of n elements. Therefore, T of n is equals to, suppose if the key which you are going to search found at the middlemost position, or array contains only one element. Okay. So, if array contains only one element, then only one comparison is required. It may found successfully or may not found successfully, only one comparison is required. Suppose if n value is greater than 1, then first you are compare the middlemost element which take constant time. You are compare the middlemost element which take constant time. Right? I will draw the diagram, you can understand. So, array contains how many elements, friends? N elements. Like starting from 1, 2 up to so on, here it is n elements. First you are compare the middlemost element, correct? Here we are having low index, it is mid index, it is high index. You are comparing the middlemost element. If the middlemost element key is matching, then you can stop the process. So, only one comparison enough. Suppose if it is not matching, then based on the key value, either you have to search towards left side or towards right side. In our example, we search towards right side, right? After comparing, we are searching towards right side. Right side. Actually, the total array contains n elements. That's why you are taking T of n. After performing compare the middlemost element with constant time, you are search towards right side. Right side at most how many elements are there? N by 2 elements are there. Right side at most n by 2 elements are there. Therefore, T of n by 2. This is a recurrence equation of binary search. We know how to solve this one by using master theorem, right? Therefore, by using master theorem, or else apply shortcut methods which I explained. N by 2 dividing by 2. Dividing by 2 means what will you get, friends? Log n base 2. So, therefore, theta of log n base 2. You no need to apply master theorem, directly can assume like this, okay? So, best case time compressor equal to omega of 1 and worst case time compressor equals to log n. Average case also log n only. Average case time compressor also by applying probability you will get log n. Clear? So, where these applications are using according to PYQ questions. Actually, what type of question asked so far in binary search? One time they asked recurrence equation of binary search. One time they asked question from match the following. Left side is binary search, right side is divide and conquer strategy. One time they asked time complexity in match the following. Left side is binary search, right side is time complexity. One time they combined this binary search application in insertion sort algorithm. Like the usual theta of n square implementation of insertion sort uses linear search to identify the position where the element to be inserted. Okay. Instead of using linear search, if I use binary search, how many number of comparisons are required or what is the running time? So that question asked in the gate paper. Means insertion sort algorithm they applied binary search. Is it clear, friends? Similarly, in heap tree construction also they applied binary search concept. Okay. Generally in heap tree, after inserting a new element, we are going to compare the parent element. That comparison will take sequentially. As a result of performing sequential, it is taking log n time in heap tree. But in the place of sequential comparison, if I use binary search, what is the time complexity they are asking? So they combine this binary search algorithm in other algorithms also. Okay. If it is clear, everything. Next. Right, friends. We successfully completed linear search and binary search algorithms also. Right. Now I am moving to the next topic. It is the right time to discuss sorting algorithms now. So we will focus on sorting algorithms, friends. Okay. Because we are having idea about recurrence relations. Right. We know how to solve recurrence relations and all. Therefore, it is the right time to discuss sorting algorithms now. Okay. You will get this revision notes. Okay. They will upload these notes. Earlier, I don't have idea that they are uploading notes or not. Otherwise, I would have written data structures and programming also in proper format. Okay. So yesterday when I came to know that this notes also going to distribute, that's why I'm writing in proper way. Next one is sorting algorithms, friends. Okay. When it comes to sorting algorithms, we need to discuss different types of parameters. Okay. So basically, if you observe gate questions, they're asking which of the following sorting algorithm is stable sorting algorithm, which of the following sorting algorithm is called adaptive sorting algorithm, and which of the following is in place sorting algorithm. Clear, friends? These are important attributes we need to discuss. And next one, we need to discuss time complexity in 3 different cases. Like time complexity complexities in 3 different cases. Case number 1, if input array is already in ascending order, input array is already in ascending order. So this is one important point we need to discuss. Okay, the input array is already in ascending order. Second case, case number 2, if the input array is in descending order, this is second case, right, friends? The third case, that is neither increasing order nor in the decreasing order. Third case, if input array elements are in neither in ascending order nor in descending order. So these are important points we need to address, friends. Okay, that's all. Okay, so whenever you are talking about input array elements in the ascending order, again we need to discuss 3 types of parameters. One is time complexity. Along the time complexities, we have to understand comparisons, number of swappings, and number of data movements. That's all. These are the only important areas we need to discuss in sorting algorithms. Okay, you take any sorting algorithm, only these are 6 items we need to discuss: whether sorting algorithm is stable or adaptive, in place, and time complexity of that algorithm, and how many comparisons are required, how many swappings are required. That's all, friends. Okay, so comparison, swappings, and time complexity based on given input values. Clear? So first we'll start with the bubble sort algorithm. Bubble sort algorithm. In bubble sort algorithm, after every pass, the largest element of unsorted part of the array will be placed in the correct place. Clear? After every pass, the largest element of unsorted part of the array will be placed in the correct place. For example, if you are having array elements, sir, 15, 80, 35, 40, and then 20. Assume their index is starting like this: 1, 2, 3, 4, 5. Clear? We want to sort them in the ascending order. Sorting means by default ascending order. So total how many elements? 1, 2, 3, 4, 5 elements are there. If 5 elements are there, 4 passes are required, because in 4 passes we will sort 4 elements. Out of 5 elements, 4 elements sorted means 5th element by default it is in the correct place only. Therefore, if there are 5 elements, 4 passes are required. Therefore, I am taking pass number 1. Pass 1. Pass 1 means I value is equals to 1, where I indicates number of passes, friends. Where I indicates number of passes, okay. Where inner loop I am taking j value starting from, so j value starting from 1 to up to n minus I, 1 to n minus I. So n minus I means like j equal to 1 and j equal to 2, j equals to 3 and j equals to 4. J equal to 4. It is using the formula n minus I, j equal to n minus I formula, okay. So therefore j equal to 1, j equal to, j equal to 3, j equal to 4. I don't want to write algorithm because it's a time based process, okay. Understand, j is taking starting from 1 up to n minus I, it is running, right friends, okay. So this is first pass. It is first pass. After first pass, which element will be placed in the correct place? The largest element will be placed in the correct place. What is the largest element here? 80. Clear friends? After first pass, we will get largest element. This is the output after pass 1. After pass 1, we will get output is 80. Means largest element will be placed in the correct place. Then we will go for second pass, pass number 2. Pass number 2 means I value equal to 2. When I equal to 2, j is starting from 1 up to n minus I, up to n minus I. So j is starting from 1 up to n minus I means n is equal to 5 elements, right? 5 minus 2, that equal to 3. So up to 3 we have to run. So j equal to 2, j equal to 3. J equal to 3. Okay. So what is the logic it is using j? J starting from 1 up to n minus I, friends. Okay. After completion of the second pass, after pass 2, second largest element will be placed in the correct place. First largest already completed earlier, that equal to 80. Second largest element, who is second largest element? That is 40. So second largest element will be placed in the correct place. Right friends, okay. Next, we will move to the third pass. I equal to 3. So when I equal to 3, j starts from 1 up to n minus I, n minus I. N minus I means n equal to 5 elements. I value equal to 3. 5 minus 3, 2. Therefore, j starting from 1, ending at 2. J equal to. After completion of this pass, after pass 3, third largest element will be placed in the proper place. Who is the third largest element, friends, here? That equals to 35. Third largest element will be placed in the proper place. Next one, we will move to the fourth pass, pass number 4. Then I is equals to 4. When I equal to 4, j starting from 1 up to n minus I. So 1 to n minus I means 5 minus 4, that equals to 1. So therefore, j equal to only 1 time. Therefore, after pass 4, the fourth largest element placed in the proper place. 80 already placed, 40 already placed, 35 already placed. Next element is, after 35 I think it is 20. 20, correct. Next one is 20. That's all. Out of 5 elements, if you sort 4 elements, 5th element automatically sorted. Now we will discuss how it will take largest element, friends. Okay, how it will sort largest element in the first pass. Just observe how bubble sort algorithm is working now. 15, 80, 35, 40, 20, where indexes are 1, 2, 3, 4, 5. Right, friends? Okay. In bubble sort algorithm, two consecutive elements are compared with respect to jth index. Means j equal to 1. So first element, second element, they are going to compare. Compare 15 and 18. Are they in increasing order? Yes. If they are already in increasing order, you no need to change the order. Keep it as it is. Okay. Keep it as it is. Next 15, 18, 35, 40, 20. Now you have to compare second element and third element, two consecutive elements. Verify 80 and 35 are in the proper order. No, they are not in the proper order. Then we need to interchange those two elements. After interchanging, means you are interchanging these two elements. We will have 15, 35, 80, 40, 20. Now you can take third element and fourth element comparison. It is third element, fourth element. Are they in increasing order? No. No means interchange the elements. Just interchange these two elements. Then 15, 35, 40, 80, 20. Now compare fourth index and fifth index. Compare fourth and fifth index. Are they in increasing order? No. No means you have to interchange. So interchange. By interchanging, you will get 20 here. It is 80. What about remaining elements? 15, 35, 40. So therefore, after first pass, which element is placed in the proper place? Which element? That is largest element is placed in the proper place. We can continue for remaining pass also. Second pass also I will explain. So that is 15, 35, 40, 20, 80. Now when j equal to 1, compare first element and second element. Are they in increasing order? Yes, they are in increasing order. Then no need to change. 15, 35, 40, 20, 80. Compare second and third index. Are they in increasing order? Yes, then no need to change them. Okay. Next one. 15, 35, 40, 20, 80. Compare 40 and 20. Are they in increasing order? No. Then you have to interchange. So bring 40 here and 20 here. That's all. After second pass, second largest element is placed in the correct place. We can continue this process for rest of the passes also. Then come back to the analysis part. Analysis point of view, we can discuss like pass number, number of comparisons, number of swappings. Right? You know 5 elements means 4 passes are required, n elements means n minus 1 passes are required. Like we can say pass number 1, pass number 2, pass number 3 and so on up to n minus 1 passes are required. Clear friends? Okay. Now look at here, first pass how many comparisons are there? Just look at comparison, first comparison, second comparison, third comparison, fourth comparison. 5 elements, 4 comparison, n elements, n minus 1 comparisons. So therefore first pass n minus 1 comparisons are there. In the worst case, there is a possibility that every time we need to perform swapping. Every comparison may need swapping if they are not in the increasing order. That's why n minus 1 swappings may be required. Second pass, 5 elements, 3 comparisons. 5 elements, 3 comparison. N elements, n minus 2 comparisons. Therefore, n minus 2. Here also n minus 2. Next one n minus 3, n minus 3. Last pass only one comparison, one swapping. It is sum of n minus 1 natural numbers, friends. Okay, sum of n minus 1 natural numbers. Therefore, total number of comparisons are sum of n minus 1 natural numbers formula n into n minus 1 by 2. Clear? And total number of swappings also n into n minus 1 by 2. Right? Therefore, total time complexity is equals to comparison plus swapping by adding these two, by performing addition operation between these two. Perform addition operation. you will get by performing addition, you will get n into n minus 1. N into n minus 1. By multiplying inside, you will get theta of n square. Right, theta of n square. Therefore, the time compressed bubble sort is equals to theta of n square. In the beginning days, they made theta of n square. Later, they realized that if the array is already sorted, we no need to go for multiple passes. Suppose, for example, if array is already sorted, apply first pass. If no swapping occurs, then array is already sorted. In that case, no need to go for second pass, third pass, fourth pass like that. Then how you are restricting this one? By using flag variables. Initially, before starting this first pass, they are setting flag is equals to 0. They are setting flag equal to 0. Afterwards, suppose if array elements are already in the increasing order, just imagine if your array input is in the increasing order like 10, 20, 30, 40, 50. Array elements already in the increasing order. In this case, you are performing comparison here, second comparison, third comparison, fourth comparison. No swapping is required. If no swapping is required, flag is not updating, flag is remains 0 only. Then before going to the second pass, check flag value equal to 0 or not. If flag value equal to 0, then no need to go for second pass. We can break the outer loop. Clear? So therefore, by using flag variables, we can reduce the time complexity if array elements are already in the sorted order. So therefore, in that case, it takes only n minus 1 comparisons. Okay. So therefore, that point I can write by using flag variables. If array elements are in increasing order, then how many number of comparisons are there? Number of comparisons, number of swappings. Number of comparisons, number of swappings. Right, friends? Okay. Suppose if array elements are in increasing order, I can use flag variables, right? So this is a case explanation using flag variables. Therefore, first pass it is taking n minus 1 comparisons. First pass n minus 1 comparisons. Then no swapping occurs. Then you can 0. Right, friends? Okay. Then control is not entered into second pass, third pass, and so on. Automatically it is terminated. Therefore, the time complexity is equal to theta of n minus 1, which is equal to theta of n. This is the case if array elements in the increasing order. Okay. If array elements are not in the increasing order, we have to use, even if you use the flag variables, worst case is theta of n square only. So when I say theta, it takes order as well as omega also. Okay. So this is all about bubble sort algorithm, friends. Okay. Is a clear bubble sort algorithm, and other parameters also I want to explain. Yes. What about bubble sort algorithm remaining parameters? Is it stable sorting algorithm or not? So you can remember IBM code. IBM company is stable sorting. Means IBM company is stable. Just assume that IBM is stable. I stands for insertion sort algorithm. B stands for bubble sort. M stands for merge sort. Okay, so therefore bubble sort is stable sorting algorithm. What is stable? We can read it from the notes, because the notes I already explained what is stable sorting algorithm, friends. Okay, so therefore bubble sort is stable sorting algorithm. Stable means relative order of equal key elements remains same even after sorting. You take equal key elements and they maintain relative order as it is even after sorting, that is called stable sorting algorithm. Next, is it adaptive sorting algorithm? Adaptive means if the pre-sortedness affect the execution time, that is called adaptive sorting algorithm. Look at here, without arranging increasing order, time complexity theta of n square. By arranging increasing order, time complexity theta of n. So pre-sortedness affect the execution time or not? Yes. Therefore, pre-sortedness affect the execution time. That's why it is called adaptive sorting algorithm. Is it in-place sorting algorithm? Yes, it is in-place sorting algorithm. In-place means within the given array itself, we are sorting elements. That's the in-place sorting algorithm. That's all, friends. These are the different input values they are asking, and applications oriented point of view. Applications point of view, what type of question they ask in the gate paper? Smartboard is really applications point of view. There is an array. Just imagine they will ask questions like there is an array of n elements. There is an array of n elements. You need to find it two elements, x comma y, from array of n elements. From array of n elements, such that x plus y is greater than or equal to 1000, like this. Then what is the time complexity for finding x comma y from array of n elements such that x plus y greater than or equal to 1000? Okay. So they may ask question like this: time complexity for finding two elements x comma y from array of n elements such that x plus y greater than or equals to 100. Right, friends? Okay. How we are going to find this type of problems? Have you done this problem earlier? If you want to find two elements x comma y from array of n elements, just apply bubble sort for two passes. Apply bubble sort for two passes. Go back to bubble sort. After completion of first pass, you are getting first largest element. You can say first largest element is x. You can say first largest element is x. And after completion of second pass, you are getting second largest element. Say y is the second largest element. You can stop the process. First largest element required how many comparisons? N minus 1 comparisons. How many swappings are required? N minus 1 swappings. Second largest element required n minus 2 comparison, n minus 2 swappings. You can stop the problem. Okay, don't continue further. Then come back to this question. It is called first largest element. First largest, which requires first pass n minus 1 comparison, n minus 1 swappings, plus it is second largest element. Second largest element. Second largest element requires n minus 2 comparisons, n minus 2 swappings. Right, friends? Okay. Therefore, total time required is equals to n. Of course, it is 4 times of n minus 2, 3, 6. So 6, which is equals to theta of n. That is the time complexity. So it is called bubble sort algorithm, friends. Okay. If you like the bubble sort explanation, simply type L in the chat box. I'm expecting from every one of you where participation is required. Right. After selection sort algorithm, friends. Okay. In bubble sort, after every pass, largest element is placed in the correct place. Whereas in selection sort, after every pass, smallest element will be placed in the correct place. Clear? So selection sort algorithm focusing on smallest element. After every pass, it is placing smallest element. That is one key point. Selection sort algorithm, it is not stable sorting algorithm. Only IBM is stable, it is not stable. But it is in place sorting algorithm. In place means within the given array itself we are sorting. That is called in place sorting algorithm. Okay. And is it adaptive sorting algorithm? No, non-adaptive. Why it is non-adaptive? Because every time it is taking theta of n square time only. Whether input elements are increasing order, input elements are decreasing order, input elements are random order, it is always taking theta of n square time only. That's what is non-adaptive sorting algorithm. Clear? I'll explain how selection sort algorithm is taking every time is smallest element. Just observe, friends. Okay. Suppose if I consider array of 5 elements, let it be 50 and then 40, 10, 30 and then 20. Right. In selection sort, we are taking pass number 1. Pass 1. That means I is equals to 1. I is equal to 1. So whenever I is equal to 1, you can assume that first index itself a min element. First index itself a min element. Now we are starting j is equals to second index onwards, I plus 1. J always starting from I plus 1 up to n. So therefore I plus 1 means 2, j is equal to 3, j is equal to 4, j is equal to 5. This is called first pass. Right, friends. Okay. In first pass we are taking elements like 50, 40, 10, 30, 20. In the beginning we are taking min is equals to first index 1, 2, 3, 4, 5. What we are considering first, min value we are taking I, min value equal to I. In that case min is equals to, what is I here? I equal to first index. So we are assuming that first index is the smallest element. We are assuming that first index is the smallest element. By assuming first index is smallest element, now I am going to compare second element with min. Second element with min. So 40 min is equal to first index. Min is equal to first index. Okay. Compare now. If a of j less than a of min, a of j less than a of min, means 40 less than 50? Yes. If it is yes, your min value must be updated, right? So min is pointing to second index now, right? Next, j equal to 3, 50, 40, 10, 30 and then 20. Right now what is min? Min is equals to 2 right now. Min is equal to 2, right? Now third index is going to compare with second index. Third index is going to compare with second index. If you find better min, update min value. Third index is 10 and second index is 40 because min is equal right now second index. Tell me 10 is smaller than 40? Yes. S means you can update min to j, that equal third index. Min value becomes jth index. Next. Now at this point of time, min is equal to third index. Right friends, okay. If min equal third index, you have to compare fourth index element with third index element. Fourth index element is 30. Tell me 30 is smaller than 10? No. No means no need to update min value. Keep it min value as it is. 50, 40, 10, 30, 20. Here min is equals to, we are having third index, right? Now take fifth index value and compare the third index value. Take fifth index, compare the third index. Fifth index means j, third index means min. Tell me 20 is smaller than 10? No. No means no need to update its value. That's all. First pass is over. After first pass is over, now we have to verify if min index not equals to I. Initially we thought that ith index is the min index. Ith index is the min index. But later it is updated, right? That's why I'm checking. Sometimes it may not be updated. So that's why if min not equal to I, what is I? 1. Min equal to 3. So min not equal to I condition is satisfied. In that case, swap A of min element with A of ith element. Swap A of min with A of I. Right friends, okay. What is min here? Third index. What is I? First index. Swap A of 3 comma A of 1. That is swap min index is equal to third index, I is equal to 1. Swap these two. And by swapping we will get answer like after pass 1. By performing swapping third and first element, so we are having 10 here, 40, this 50 will be placed here, 50, 30, 20 like this. Is it clear friends, okay? So successfully we got first to smallest element now, first smallest element. I'll explain second pass if you want, okay? Shall I explain second pass also? Third pass onwards you can understand by yourself, okay? Second pass I'll explain. Pass number 2. Pass number 2 means I is equals to 2. Whenever I equal to 2, j loop is starting from I plus 1. Okay, I plus 1 means like j is equals to I plus 1 means 2 plus 1 3, j equal to 4, j equal to 5. Because we have 5 elements, friends. We have 5 elements. Okay. Therefore, we are having elements now. After first pass, what we are having? 10, 40, 50, 30, 20. 10, 40, 50, 30, 20. Clear friends, okay? 10, 40, 50, 30, 20. Now, you can assume that min is equal to second index. Do you know what is meaning of second index now? Means up to first index already sorted. Up to first index already sorted. Second index onwards we need to sort. Okay. Therefore, second index element itself min. We can consider min is equal to I. Right. Therefore, min is equal to I. I means here second index. I equal to second index. You have to remember compulsory all these values, okay? Because you are aiming for IIT. It is getting admission IIT is not easy task. You should be desired to enter into IIT, right? It is possible only by putting 14 hours per day. I think 14 hours is not enough, but you need to work minimum 14 hours. Sometimes we think that we are working very hard, but it is honestly it is not true. Okay, so many people are working more than 14 hours in a day. Okay. So that is compulsory. You have to work minimum 14 hours to get admission in IIT. Then only you can enjoy that admission process also, right? Without putting more efforts, if you get admission in IIT, you will not feel that you are great, right? Internally, you have to feel that you are great. You're great. Suppose while I'm teaching, if I teach any concept in a simple way, I feel myself is proud. Really, I feel very happy. That's for my self happiness purpose. I'm writing everything in the proper way, right? So therefore, sometimes I may not feel self-happiness. Then in that case, I fail in the task. So therefore, if you want to feel self-happiness, compulsory you have to work hard and enter into IIT friends. Okay, it is not a single day work. Continuous efforts are required. You know, actually, I don't know how many of you attended revision classes. I conducted revision class almost 45 hours classes earlier. Algorithm and data structures classes. Many students attended, approximately 60-70 students attended. Every day I used to conduct revision classes. Maybe some other students are having classes, that's why they didn't attend. Okay, so my intention is, suppose at least 2-3 students in all IITs, our students are there. Okay, if 2-3 students remember the content, that's enough for me as a teacher. Okay, that is my ultimate goal. Okay, let me come back to here friends. Small motivation. M is equals to 2. Now you're taking third index. Third index means, like, what does it mean? Third index onwards you have to compare. Compare 50. 50 is going to compare second index. 50 is smaller than 40? No. No means no need to update min index. Okay. That is 10, 40, 50, 30, 20. Now min index element is equal to second only. Right. Now you can compare fourth index with min index. That is 30 is going to compare with second index. Is 30 smaller than 40? Yes. Yes means you have to update min value. So min is updated to fourth index. Right friends. Okay. Next 10, 40, 50, 30, 20. Now your min value is equals to fourth index. Now compare fifth index with the fourth index. That is 20 smaller than 30? Yes. S means you can update min value. Min is equal to 5. That's all. After updating, verify min not equal to I or not. Sometimes what happens, min may be equal to I. Means smallest element already in the correct place. If smallest element already in the correct place, you no need to swap the element. So therefore I am checking the condition. If min not equals to I, then swap the elements. Swap A of min, comma A of I. Swap A of min, comma A of I. So it means which element you have to swap? You have to swap fifth index and second index. Fifth index and second index. Swap these two ends, fifth index and second index. Therefore, after pass 2, you'll get elements are fifth index and second index. It is 10. Second index swapped with fifth index, that is 20. So 50, 30, it is 40. That's all. 10, 20, 50, 30, 40. Now after second pass, we got second smallest element. Earlier we got first smallest element. This is the way we need to continue the process, friends. Okay. Now come back to the analysis part. If we consider passes, pass number, comparisons, and number of swappings. Just go through first pass, second pass, third pass, and so on. N minus 1 passes. Right friends. In first pass, how many comparisons we made? In first pass, like first comparison, second comparison, third comparison, fourth comparison. If 5 elements are there, 4 comparison. N elements are there, n minus 1 comparisons. How many swappings are there? Only one swapping is required. Only one swapping. Therefore, first pass, n minus 1 comparisons, only one swap. Second pass, how many comparisons, friends? N minus 2 comparisons. So, n minus 2 comparison. How many swappings in the worst case? One swapping is required. Therefore, by continuing this process, it is n minus 3 comparison, one swap is required, and so on. One comparison, last one comparison, one swapping is required. Therefore, total number of comparisons. It is sum of n minus 1 natural numbers, right? So sum of n minus 1 natural numbers formula n into n minus 1 by 2. It is sum of 1 is added n minus 1 times, that's why it is n minus 1. Clear, friends? Okay. Therefore, time complexity point of view, comparisons plus swappings, which is equivalent to, it is n square, it is n square is dominating, that's why theta of n square. Whether input elements in the increasing order, decreasing order, random order, always it is taking theta of n square. Then what type of questions asked so far in selection sort? One time they ask question is, how many number of swaps are required in selection sort? They provide options like this. How many number of swaps are required for selection sort? Number of swaps required for selection sort is theta of n. This question asked in the gate paper. Okay. So only one time they ask in selection sort, but remaining time they combine selection sort algorithm with the remaining algorithms. Applications point of view, it is same as previous one. We need to find two elements x comma y from array of n elements such that x plus y must be less than or equal to 1000. You need to find two elements x comma y such that x plus y must be less than or equal to 1000. In that case, you can apply first pass. Of selection sort, where first pass requires n minus 1 comparisons plus 1 swapping in the worst case, right? And apply second pass, you will get second smallest element. Second pass requires n minus 2 comparison and then 1 swappings, right, friends? Okay. Therefore, total time required is equals to n, and n we can say theta of n. That's all. So these are applications, friends. Okay. If you like it, simply type L in the chat box. It is a bubble sort selection sort algorithm. You want to scroll down once? Yes. We are sending these notes also. You don't worry. Okay. So we are providing these notes. You don't worry about the notes, friends. Okay. I'll move to the next topic. You believe me, data structures and algorithm topic is so easy for GATE exam point of view. You will get minimum 20 marks, maximum 22 also possible. So my point of view, student after attending class notes, means after reading class notes and after solving all PYQs from 1987 to 2024 papers, 100% guarantee they will score minimum 18 marks from algorithm, data structures and programming. It is my belief. Okay. But how we are understand that question is important. You believe me, after completion of the GATE exam paper, just come back to home and see class notes once and see PYQ questions. Definitely that question belongs to either class notes or PYQ model. Okay. So anyway, after GATE exam, we will discuss that point also. Because it is not first year, friends, from many years, almost from 17 years onwards I am teaching. So with the experience I am telling all these points. Okay. Kindly note it. Next one is insertion sort algorithm. Bubble sort purpose is placing largest element. Selection sort purpose is placing smallest element. Where insertion sort meaning is some part of the array is already sorted. Then we want to insert an element into its proper place among the sorted elements. For example, just consider this array. Suppose we are having elements like 1, 2, 3, 4, 5, 6 elements are there. Okay. And array size is 7. And first 6 element already sorted. Let it be 20, just look at this array. In this array, some part of the array is already sorted and your objective is to insert key into in its proper place among the sorted array. Okay. Insert key into in its proper place among the sorted part of the array. That's all. Then how we are going to insert? Since it is sorted up to 6, therefore you can consider I equal to 6. I equal to 6 means up to 6 element already sorted. Actually, I need to start from second index, but there is no time for us. That's the reason I'm assuming that up to 6 elements already sorted. I hope you are getting my point, right? Generally, we want to start from second index. Second, third, fourth, fifth, like that you can continue. So directly I'm starting from sixth index. So I equal to 6 means up to 6 index elements already sorted. Now you want to place this key. So key is equal to 7th index element. I want to place that 7th index element in the proper place. So in the place of I, in the class notes, I remembered I had taken this variable is j. You take j is equal to 6 now. Okay, j equal to 6. So by taking j is equal to 6, it means that up to 6 index elements already sorted. Up to 6 index element already sorted. Then you have to place 7th index element in the proper place. Is it clear, friends? Okay. So then how you are going to do? Just you are going to compare 70 with 5. 70 with 5. Okay. Let me keep it as I only, friends. Okay. So comparisons are looking like this. 70 greater than 5. Yes, condition true. If 70 greater than 5, condition true. What is 5 here? 5 is key. What is 70? 70 is nothing but A of 5. If A of 5 is greater than key, A of 5 greater than key. What is I value right now? 6. So A of 6 that equals 70. 70 greater than 5, true. If the condition true, we have to shift A of 5 to A of 5 plus 1. You have to shift A of 5 to A of 5 plus 1. So therefore, if the condition true, we have to copy A of 5 into A of 5 plus 1 location. So test this condition. Yes, after testing, copy A of 5 into A of 5 plus 1 location. Yes, A of 5 is copied into A of 5 plus 1 location. Then afterwards, what I have to do? So I had to do I is equals to I minus 1. Okay, I equal to I minus 1. Maybe if I write here, you will get confusion. Give me 1 point, friends. So first, what you are going to check? You are going to check I value greater than key or not. If this condition true, then you have to shift A of 5 into A of 5 plus 1 location. Means A of 5 plus 1 is equal to A of 5. After shifting, you can decrement I by 1. I is equal to I minus 1. After decrementing, check the condition. Is I value greater than 0 or not? I value greater than 0 or not. Okay. So therefore, first check the condition A of 5. What is I value right now? I equal to 6. I value equal to 6. Therefore, A of 6 greater than key. Key means 5. Yes, it is true. True. True means you have to copy 70 into this place. That equal to 7th place. A of 5 equal to A of 5 plus 1, right? Sorry, A of 5 plus 1 equal to A of 5, right? So I plus 1 means that equals to 6 plus 1, 7. A of 7 equal to A of 6. So let me write this one. A of 7 is equal to A of 6. That's all. What is your key value? Key value equal to 5. Remember that one. Okay. After copying, then decrement I by 1. I becomes 5. Now check the condition. I greater than 0. Yes, condition true. Condition true. So if the condition true, now again it is A of 5 greater than key element. A of 5 greater than key element. What is A of 5? That equals 60. Yes, 60 greater than 5. True. Then copy A of 5 into which location? A of 6 location. It means that you are shifting this element this place. Right, friends? After shifting I equal to I minus 1. I becomes 4. Check the condition I greater than 0. Yes, condition true. If condition true, then again A of 5 greater than 5. Means A of 4 greater than 5 or not? What is A of 4? 50. 50 greater than 5? Yes. S means copy A of 4 into A of 5 location. like this. After copying decrement I by 1, I is equals to 3. Check the condition I greater than 0. Yes, I greater than 0 condition satisfied. Then A of 3 greater than 5. Yes. Then copy A of 3 into A of 4. Means you are shifting this element to here. I value equals to 2. And verify this condition. Yes, I greater than 0 condition satisfied. Right, friends? Okay. Next one, A of 2 greater than 5. Yes. Then copy A of 2 into A of 3. After psi becomes 1. Verify I greater than 0. Yes, I value greater than 0. It means you can understand it is copied here. Okay. Now I value equal to 1. Then A of 1 greater than 5. True. True means we can say A of 1, A of 2 is equals to A of 1. Means you have to shift this element to this location. After decrement I by 1, I becomes 0. Right? I becomes 0. Then check the condition I greater than 0. No, condition fail. I greater than 0 condition fail. So the moment I greater than 0 condition fail, what you have to do? You have to copy key element. The condition fail, then copy key element into A of I plus 1 location. A of I plus 1 is equal to key. That's all. What is I plus 1? I equal to 0, right? 0 plus 1, that is A of 1 is equal to key. Key how much? 5. It means that this location occupied by 5. So therefore, A of 1 location occupied by 5. 20 already shifted to next location. 30 already shifted. That's all. This is a insertion sort algorithm process. Here I explain only one pass. Just I explain only one pass. Clear, friend? That is last pass I explained. Now analysis. How it is taking analysis? Analysis point of view, actually here we started from 6th index, right? We supposed to start from second index. Second index, okay? So therefore analysis is looking like this. So in the insertion sort algorithm point of view, an array and index and in elements where A is an array with starting index is 1. With starting index 1, friends, okay? So in that case, what we have to do, we can start for loop from j equal to 2. What does it mean? Up to first index already sorted. Up to first index already sorted. Second index onwards we want to arrange. Otherwise what happened? We don't know to whom I have to compare first index, right? Suppose if you start from j equal to 1, the previous index elements are not there. In that case, I cannot compare the previous index elements. That's why I have to start from second index by assuming first index already sorted. So j less than or equal to n, j plus plus. Since you are taking second index element, therefore your key is equals to A of j, second index element, and I is equals to, you can take previous element, that is j minus 1, I equal to j minus 1. Now you are using while loop condition. As long as I greater than 0, okay, while I greater than 0 and key element means A of I greater than key element, both the conditions are true. In that case, what we are going to do, we can shift I into I plus 1 location. A of I equal to I plus 1. After reduce I by 1. After failure of while loop condition, copy your key value into A of I plus 1 location. Then you can close this one. That's all. This is called insertion sort algorithm, friends. Okay. So based on this, how we are going to give analysis. So we are taking it is pass number, comparisons, data movements. Similarly, taking second case, comparisons, data movements. Suppose if input elements are in decreasing order, input element is in decreasing order. If input element are in increasing order, so these two cases we need to discuss here. Okay. Now take pass number 1, pass number 2, pass number 3, pass number 4, up to so on pass number n minus 1. Now come back to this problem. If it is last pass, we are explained, right? Means total 1, 2, 3, 4, 5, 6, 7 elements are there. After sorting 6 elements, we are talking this one 7th element. Therefore, 7th element, how many comparisons are required? Just observe. So this is 7th index element you want to place, right? Like how many comparisons? 1, 2, 3, 4, 5, 6 comparisons. So 7th element if you want to pass, if you want to place, then 6 comparisons are required. And how many data moments are there? Data moments, 6 data moments are there, right friends? If it is nth element, if it is nth index element, n minus 1 comparisons are required, n minus 1 data moments are required. Am I right or wrong? Provided array elements are in the decreasing order. Okay. So what I'm trying to say, just observe. Suppose if array elements are like 50, 40, 30, 20, 10. If array elements are decreasing order, in that case what happened? We are starting from, it is first index, second index, third index, fourth index, fifth index, correct? Fifth index. Now when j is equal to 2, we are starting second index, j equal to 2. When j equal to 2, whatever the key value equal to second index, that equal to 40. Whatever I value, j minus 1, that is 2 minus 1, 1. Now compare I value with the key. Compare I value with the key. That is a of 1, that equal 50. 50 greater than 40? Yes. S means you have to shift 50 here. Let's shift 50 here. After shifting 50, decrement I by 1, I becomes 0. It means I becomes 0 means I while loop condition fail. This condition fail, I greater than 0 condition fail. Then copy key into a of I plus 1. So a of I plus 1 is first location. So you already shifted 50 here. It is 30 and 20, right? 20. Then what about it is 10? Then what about 40? 40 must be copied here. So therefore, second index element is sorted. second index element is sorted. Therefore, if the array elements are decreasing order, first pass only one comparison, one data moment is required. One data moment. If I go to second pass, so first pass 1 and one data moment is required. Suppose if I go to second pass what is going to happen? So second pass key value equal to 30. If key value equal to 30, 50 is comparing with 30, 40 also comparing with 30. Therefore, 2 comparisons, 2 data moments, 3 comparison, 3 data moments, 4 comparison, 4 data moments. Like that, n minus 1 comparison, n minus 1 data moments. Clear, friends? Okay. If array elements are in the decreasing order, it is taking this way. Therefore, the total time complexity is comparisons are n into n minus 1 by 2, movements are n into n minus 1 by 2. By summing up this total, we will get time complexity. Right, friends? Okay. The time complexity equals to n into n minus 1. By adding these two, we will get theta of n square. That's all, theta of n square. Clear, friends? Okay. Suppose if array elements are increasing order, for example, just listen. If array elements are increasing order, like for example 10, 20, 30, 40, 50. Now, according to this algorithm, j equal to 2, so we can consider j equal to second index. What about key? Key is equal to second index, that equal to 20. What about I? I equal to j minus 1, that is 1. Now, compare a of I with key element. Okay. Tell me 10 greater than 20? No, 10 greater than 20 condition fail. Means this condition failed. A of I greater than key condition fail. If the condition fail, come out of this loop, copy key into A of I plus 1. Copy key into A of I plus 1 is key equal 20, I plus 1 is second location. Second location we are going to copy. Okay. Second location we are going to copy. It means that only one comparison, one data moments, no data moments. Because it is not called data moment. Data moments means with respect to this value we are calling data moment. Okay. So, A of I location element is moving to A of I plus 1 location element. Okay. This is not the data moment we are talking. So, here there are no data moments. With respect to comparison, there is no data moment, but only one comparison is required. Okay. Next one. If j is equal to 3, j is equal to 3, then key is equals to 30. Now, I is equal to second index. Now, compare second index element 20. 20 greater than 30, 20 greater than 30 false, means again this condition false. If the condition false, simply copy key into A of I plus 1, that's all. Means this data moment is not required. Therefore, only one comparison, no data moments. One comparison, no data moments. Like that, everywhere one comparison, no data moments. Total number of comparisons are n minus 1 comparisons. Data moments are 0. There are no data moments. Therefore, in this case, time complexity is equals to theta of n. In this case, time complexity equal to theta of n. Right, friends? So, if array elements in the decreasing order, time complexity theta of n square. If array elements in the increasing order, time complexity theta of n. So, time complexity differ based on the input array. That's why it is called adaptive sorting algorithm. Insertion sort is stable because in IBM, I is insertion sort, you can remember like that. Okay. And it is in place sorting algorithm. It is stable algorithm, it is in place sorting algorithm, it is adaptive sorting algorithm because input array increasing order theta of n, decreasing order theta of n square. How binary search application is applicable in insertion sort? In the insertion sort, just observe how binary search application is applicable. But could you please confirm that everything is clear so far? Actually, in one of the gate paper, they asked the question. I am reading question in slow format, just observe, friends. Usual theta of n square implementation, of insertion sort uses linear search to identify the position where the newly inserted element will be placed. Okay. For example, see here. Usual theta of n square implementation means it is possible only if array elements are decreasing order. Right? If array elements are decreasing order, then only it is possible theta of n square. So suppose if you want to place 5, how we are performing comparison? You are comparing with A of 6, A of 5, A of 4, A of 3, A of 2, A of 1. This is called sequential search, right? Sequentially you are performing comparisons. Therefore, they ask question this way: in the usual theta of n square implementation of insertion sort, if they use linear search to identify the position where we have to insert element, okay, instead of using sequential search, if I use binary search, what is the running time? What is the running time they're asking? Clear, friends? Okay. Actually, we are comparing 5 with every element without skipping. This is called sequential search. Instead of sequential search, if I apply binary search, okay, then what is the worst case running time they're asking? But here, student point of view, one important thing you have to remember. Actually, here they are asking question. Just observe. In the insertion sort, they are applying sequential search generally to identify the position. If you apply sequential search, how many comparison it is taking? And then how many swappings it is taking? There are no swappings actually, only data movements. Data moves. Okay. Now they are asking if you apply binary search, how many comparisons are there? How many data movements are there? So this is the way we need to understand this concept, friends. Okay. Pass number 1. So we need to discuss pass number 1 and pass number 2, pass number 3 up to so on n minus 1. You know, in sequential search we already discussed. We don't want to waste time for that one. Okay. In sequential search, if I apply worst case analysis, first pass 1 comparison, 1 data movement, second pass 2 comparison, 2 data movements, third pass 3 comparison, 3 data movements. Correct? 3 data movements. That's what I explained just now. In the last pass, we need n minus 1 comparisons. How many data movements? N minus 1 data movements are required. That is the last pass. Right, friends? N minus 1 comparison, n minus 1 data movements are required. Please excuse me. Actually, I didn't write. Oh my God. Okay, leave it. Okay, we don't want to extend. Let me complete it quickly. So it is first pass, second pass, third pass up to sun n minus 1 passes. So total number of comparisons here, the total number of comparisons, we are having n into n minus 1 by 2, correct? Total number of comparison. How total number of data movements n into n minus 1 by 2. That's why by adding these two, we are getting answer is theta of n square. This is called sequential search. But instead of applying sequential search, if you apply binary search, then what is the worst case running time they're asking? See, if you apply binary search, just observe, friends, how to apply binary search. Please understand. This array is already sorted, right? This array is already sorted. If it is already sorted, you can consider low index is 1, high index is 6. Then compute mid index, 1 plus 6, 7, 7 by 2, 3.5, floor of 3.5, 3. So directly take third index. Directly take third index. Means third index element is greater than 5 or not, we have to verify. What is third index element? 40. 40 greater than 5? Yes. Yes means we have to shift this 40 to the next location. But here, friends, please understand, before you shift 40 to next location, you have to shift 50 to next location, right? That is reason maybe comparisons are significantly reduced. Comparisons are significantly reduced, but data movements remain same, right? So first you have to, after performing comparison, 40 greater than 5, 70 shifted next location, 60 shifted next location, 50 shifted next location, and 40 shifted next location. Therefore, comparisons are reduced significantly, but movements remain same. How many comparisons reduce means apply binary search algorithm. If sequential search takes n comparison, binary search takes log n. If sequential search takes k comparison, binary search takes log k. If sequential search take one comparison, it will take log 1 comparison, right friends? But movement remains same. If it is take 2 comparison, we can take it as log 2 comparison, movement remains same. So it is log 3 comparisons, movement remains same. Up to so on, it is taking log n minus 1 comparisons, right? So movements remain same, that equal to n minus 1. N minus 1. Clear friends, okay? So therefore, total number of comparisons are, sum up all the values. Total number of comparison, log 1 plus log 2 plus up to so on plus log of n minus 1. I want to simplify this value in a separate location. Right friends, okay? What is value log 1 plus log 2 plus log 3 up to log n minus 1? Just look at here, I am going to simplify it. Log 1 plus log 2 plus up to so on log n minus 1. This total value we can also make it as bounded by log 1 plus log 2 plus up to so on log n. I am taking upper bound for this, Actually, it is for only up to n minus 1. I am taking up to log n. So, which we can also write as log of 1 into 2 into 3 into up to so on n. 2 into 3 into up to so on n. So, which is nothing but log n factorial. Log n factorial. But we know that n factorial value always less than or equal to n power n. N factorial value always less than or equal to n power n. Therefore, I can substitute here less than or equal to log of n to the power of n. So, less than or equal to n log n. Therefore, comparisons are significantly reduced. How many comparisons? That is n log n comparisons. N log n comparison. How many movements are there? N into n minus 1 by 2 movements. N into n minus 1 by 2 movements. I cannot delete that row, that is the reason. Now come back here friends. If I use sequential search, the time complexity is theta of n square. By using sequential search, time complexity is theta of n square only. Even applying binary search, we are having n log n plus n into n minus 1 by 2. Who is dominating? N into n is dominating, which is n square. Therefore, binary search also it is taking overall time complexity theta of n square only. Listen question once again. Usual theta of n square implementation of insertion sort uses sequential search to identify the position where we have to insert the element. In the place of sequential search, if I use binary search, what is the worst case running time? Worst case running time remains same, that is theta of n square. Worst case running time remains same, that is theta of n square. But same question they may ask in the next year paper, means 2025 paper. Okay. In the place of worst case running time, they may ask worst case comparisons. Worst case comparison means theta of n log n. That last line is most important friends. If they ask worst case comparison theta of n log n, if they ask worst case comparison n log n, total time if they ask theta of n square time. Okay. So is it clear binary search application with insertion sort? If it is clear, simply type B in the chat box. B stands for binary search application is clear. Clear, right? Yes. Next one. If input elements in increasing order completed, decreasing order is also completed. Then there is another case, that is input elements in random order, neither increasing nor decreasing order. Neither increasing nor decreasing order. In that case, another case that is neither increasing nor decreasing, it will take theta of n plus d. What is D stands for? D indicates number of inversions. Number of inversions. You know that inversion means in array for I less than j, if a of I greater than a of j, that is called inversions. Therefore, insertion sort time complexity is theta of n plus d in the average case, means neither increasing nor decreasing. In general, time complexity of insertion sort is equals to theta of n plus d. D equal number of inversions. So, if its array is already in increasing order, D is equals to n into n minus 1 by 2. Inversions are possible if array in the decreasing order. And D is equals to 0 if array in the increasing order. Remember these two cases, okay? So, therefore, the time complexity theta of n plus n into n minus 1 by 2, which is equal to theta of n square. Whereas in this case, it is theta of n plus 0, which equal to theta of n. Okay. So, number of inversions, if array elements are in the decreasing order, if array elements in the increasing order. Clear? So, number of inversions are n into n minus 1 by 2 if array elements in the decreasing order. Number of inversions are 0 if array elements in the increasing order. Clear, friends? Okay. In the GATE exam, they ask one question: what is the time complexity of insertion sort? What is the time complexity of insertion sort if the array contains at most n inversions? At most n inversions. If they mention at most n inversions, the time complexity is theta of n plus n, n plus n, because at most n inversion they mention. Actually, time complexity formula theta of n plus d, right? At most n inversion means theta of n plus n, that equal theta of 2n. Theta of 2n means theta of n. That's all. So, this is complete information about insertion sort. So, theta of n plus d, d indicate number of inversions. If array elements are decreasing order, n into n minus 1 by 2 inversions are there. If array elements are increasing order, d value equal to 0. That's all. So, with this we successfully addressed insertion sort also. So, next sorting technique is merge sort algorithm, right, friends? Okay. So, some theoretical points here. Merge sort algorithm uses divide and conquer technique. Merge sort algorithm uses divide and conquer technique. This question also asked 1 or 2 times in the GATE paper. Clear, friends? It is using divide and conquer technique. And in merge sort algorithm, we are using a pattern is called merge pattern. Okay, that is nothing but suppose if L1 comma L2 are two sorted lists, L1 comma L2 are two sorted lists, such that cardinality of L1 is equals to m elements, cardinality of L2 is equals to 10 elements. Cardinality means number of elements. So, L1 comma L2 are two sorted lists of size m comma n respectively. If you want to merge them into single sorted list, then how many comparisons are required for merging them into single sorted list? Number of comparisons required. And how many data movements are required? Let me take simple example to explain this topic. So assume that we are having two sorted list. I am calling this sorted list is L1 and it is L2, two sorted list, right friends? Okay, assuming we are having elements are 10, 16, 20 and 12, 18, 24. Clearly L1 is sorted, L2 is also sorted. I want to merge them into single sorted list where this array contains indexes like this 1, 2, 3, 4, 5, 6. So how to merge them into single sorted list? Assuming I is a variable which is pointing to index of the L1 and j is a variable which is pointing to index of L2, right friends? Okay, now consider it is an auxiliary array. Auxiliary array means extra space which we are using auxiliary array, and we are using a variable k which is tracking index of A, right? Then how can I merge these two sorted list into single sorted list? So it is performing comparison like this. If L1 of I value is less than L2 of j, L1 of I less than L2 of j, or even you can take less than or equal, because sometimes maybe duplicate elements also possible, right? That's the reason. If L1 of I less than or equal to L2 of j, then who is the smallest element? L1 of I. Therefore, copy that L1 of I into A of k. A of k is equal to L1 of I. Clearly in our example, it is comparing 10 and then 12. 10 is going to compare to 12, right friends? Okay, who is the smallest element between these two? 10. Therefore, you can copy 10 into A of k location, like 10 is placed in this case. After copying, since you copied L1 of I, then increment I value, right? So it is pointing to next index, and also increment k value, means k is pointing to next index. This is the case if L1 of I less than or equal to of j. Clear friends? Okay. Suppose if this condition fail, if this condition fail, then who is the smallest element? L2 of j is smallest element. Let me continue now. Now compare here 16. 16 is going to compare with 12. 16 less than 12. 16 less than 12. This condition fail. If this condition fail, we can execute remaining part. What is the remaining part? You have to copy L2 of j. If this condition fail, else copy L2 of j into A of k. It means L2 of j means 12. We are copied into A of k. 12. After copying, increment k value, increment j value. J plus plus, right friends? J plus plus, and then k plus plus. Okay. So therefore, after copying 12 here, I am incrementing j value and also I am incrementing k value. Clear friends? Now continue this process. Take second element here 16 and here second element is 18. Compare those two elements now. So we are performing comparison between 16 comma 18. Who is the smallest element? 16. Therefore copy 16 in third index. After copying, you can increment corresponding pointer, that equal I is incremented and k also incremented to next location. Right friends? Okay. Next you can perform comparison 20 and 18. 20 and 18. Who is the smallest element? 18. Copy 18 here. So copy 18 here. After copying, increment j value, right? Also increment k value. K value. Next comparison between 20 and 24. 20 and 24. Who is the smallest element? 20. So therefore copy 20 here. Afterwards increment I pointer or I index variable and also increment k by using this coding part, right friends? This time L1 already exhausted, means L1 list already completely copied into A. Therefore remaining part of the array we can copy directly because it already sorted. So directly can copy remaining elements here. So this is called merging pattern friends. Okay, this is called merge algorithm. Therefore merge algorithm, how many comparisons it is taking? 1, 2, 3, 4, 5 comparisons. So one list contains 3 elements, another list contains 3 elements, 3 plus 3, 6 elements are there, but we are having only comparisons 5. So therefore, in general, number of comparison we are writing like this, see. Number of comparisons are m plus n minus 1, m plus n minus 1. Here 3 elements, here also 3 elements, 3 plus 3, 6, 6 minus 1, 5 comparison. Clearly 5 comparisons are there, 5 comparisons. How many data movements are there? Data movements means, just observe friends, after comparing 10 and 12, 10 is moving to this place. After comparing 16 and 12, 12 is moving to this place. How many data movements means, from first list we are having 3 data movements. From first list 3 data movements. Second list we are having again 3 data movements. Therefore, total number of data movements are m plus n. Therefore, the overall time complexity for merge algorithm, time for merging is equal to theta of, who is dominating? Comparisons or movements? Movements are dominating. That's we can take movements time complexity, that is theta of m plus n. That's all. Okay, theta of m plus n. So this is a time required for merging 2 sorted list into single sorted list. Now I can take help of this algorithm in order to apply merge sort algorithm. Clear friends? Okay. Now we will discuss how exactly merge sort algorithm is working. Assume that there are 8 elements in the array. So assume that we are having 8 elements in the array. Observe how exactly merge sort algorithm is working. In merge sort algorithm, we are dividing array into 2 subarrays, and each subarray is of size n by 2. Suppose there are n elements are there, we have to make them into 2 sublists, each sublist of size n by 2. Clear friends? Okay. So here lower index is equal to 1 and the higher index is equals to 8. Higher index equal to 8. Now it is computing mid index between these two. So 1 plus 8, 9 by 2, that equal 4.5. Floor of 4.5 means 4. Therefore, it is divided into 2 equal parts, exact at 4th index. At 4th index. Right friends? Okay. So by dividing them into 2 equal parts, left part contains indexes starting from 1 to 4. Right part contains index starting from 4 plus 1 to 8. Means if a construct is low, you can consider low index, it is called mid index, and it is called high index. Right friends? Okay. Now left part contains indexes starting from low 1 to up to mid index. It is mid plus 1, that equals 5 to up to 8. How long we can continue the division process? In divide and conquer, if the list contains only one element, we can assume that it is already sorted. If the list contains more than one element, we have to continue this division process. Clear? So here list contains how many elements here? 4 elements are there. That's why it is not sorted. We have to continue this process until we get only one element. Therefore, let me divide further. Right friends? Okay. If I divide it further, it is dividing like this. 1 plus 4, 5 by 2, 2.5. 2.5 means we can take first index 1, second index is 2. Next mid plus 1, 3 to 4. Again you can divide it further. Now it is first index, it is second index. Means we are continuing this process until your list contains only one element. Right friends? Afterwards, what are the elements are there here? Just observe. First index we are having 40 and then 10, 40 and 10. If the list contain only one element, it is already sorted, then you can apply merge process, which I explained just now. Okay, it is sorted list, it is also sorted list. Can you merge two sorted list into single sorted list by using merge algorithm? Yes, it is called auxiliary space now. Therefore, actually merge algorithm working from bottom to top approach. Therefore, 40 and 10. So who is smallest element? 10. Therefore, shift 10 into A of k. Assume it is A of k. It is L1 of I. It is L2 of j. L1 of I is compared with L2 of j. So L2 of j is smallest element. Move this element here. Afterwards, this list already existed. Then copy remaining elements of L1. That is 10, 40. So this array is already sorted now. Right, friends? Okay, this is the first pass of merge sort. Therefore, first pass of merge sort algorithm contain elements are for 10, 10, 40. Let me write down here. After pass 1, the output of the array. Then after pass 2, we need to discuss. In the exam, there is a possibility to ask the question, what is the output after particular pass? Right, friends? Okay, after pass 1, we are having elements are 10, 40. 10, 40. So these two elements are sorted. Remaining elements are not yet sorted. Please understand that point. Now, after completion of this one, now again we are dividing into two equal parts, where we are having third index and then fourth index. What about third index element, friends? That equals 60. Fourth index is 50. Third element is 60. Fourth element is 50. So it is 60 and is 50. Then merge these two. Tell me, is it sorted list? Yes. Only one element is sorted. It is also sorted. Merge them into single sorted list. That equals 50 and then 60. Therefore, after second pass, 10, 40 and 50, 60 got sorted. Two passes over, friends. Okay, two passes over. Next, at this point of time, it is one sorted list, it is another sorted list. Merge them into single sorted list by applying merge algorithm. It is comparing 10 and 50, we had shift 10. After comparing 40 and 50, it is shifting 40. Now this list already exhausted. Remaining elements of this list must be copied. 50 and then 40. Please excuse me. 50 and 60. Right? 10, 40, 50, 60. That is output after third pass. After third pass, this output. Remaining elements are unsorted. Okay, please understand. Remaining elements are as it is only. I'm not writing, but remaining elements are as it is only. Right, friends? Okay. Now we are moving to fourth pass. Again, it is divided into two equal parts. Right, friends? Okay. Apply the same procedure, which is equal to fifth index and then sixth index. Fifth index element is equals to 20 and sixth index element is 5. Sort these two elements, 20 and 5. We can get elements are 5, 20. 5, 20. So there is therefore this output after next pass. So we are having 10, 40, 50, 60. This part already sorted. Now which part we sorted now? 50 and 5 and 20. This is sorted. Clear, friends? Okay. Next one, 7th index and 8th index. 7th index equal to 80 and 8th index equal to 25. Therefore, compare these two. So 25 shifted to parent level and 80 shifted here. Right, friends? Okay. So we are having index here. It is 5, 6, 7, 8. Therefore, this output after next pass, 25 and 80. right? If I go to next pass, then 10, 40, 50, 60, these two will be sorted like 5, 20, 25, 80, right friends? The last pass, which is pass number 7, we have to sort these two sorted list into single sorted list. So 10 and 5, we can get 5, and 10 and 20 will get 10, 40 and 20 you will get 20, 40 and 25, 25, 40 and 80, 40, and then 50, 60, 80. That's all. This is your final sorted list. Final sorted list. Okay. So come back to here, friends. So we are having elements here 5, 20, 25, 80. By comparing, we will get 5, 10, 20, 25, 50. Where is 40? 40, 50, 60, and then 80. This is your final sorted array. Now you want to discuss time complexity of this merged sort algorithm. Please understand, remaining elements we have to write down. Okay, so I didn't write them here because it's a revision class. I want to discuss time complexity for this problem. Suppose if I construct recurrence equation, let T of n is equals to time complexity merging to sorted list, or time complexity for merged sort algorithm. Okay, time complexity merged sort algorithm. Then T of n is equals to, just look at the process how we complete this algorithm. The first thing is we completed left subarray first. We completed left subarray, right? So left subarray is taking how much time? If the array contains n by n elements, the time required for sorting an element is T of n. So you can imagine like this. The time required for sorting n elements, we are taking this T of n, friends. Okay, T of n. First, what is the task we are performing? You are sorting left subarray, where left subarray contains how many elements? Left subarray contains n by 2 elements. That's the time required for sorting n by 2 element is T of n by 2. Means first we are sorting left subarray. So clearly we sorted left subarray. Afterwards we entered into right subarray. Therefore, time required for sorting right subarray is taking T of n by 2. Now what we are doing afterwards? After sorting left and right, are you stopping the process? No, right? You are merging these two into single sorted list. But just now we discussed one formula. If one list contains m, another list contains n, to merge them into single sorted list, it takes theta of m plus n. So therefore, to merge this list of size n by 2 with another list of size n by 2, it is taking theta of n by 2 plus n by 2. Therefore, recurrence equation, look at here. First sort left part with T of n by 2. Sort right part with time theta of T of n by 2. After, don't stop the process. You have to merge these two sorted lists into single sorted list. So merge this list and this list into single sorted list. So therefore, that merging time is equals to theta of one list of size n by 2, another list of size n by 2. In the beginning, I told you, right? Merging two sorted list of size m comma n takes theta of m plus n. So one list is n by 2, another list is n by 2, which is equals to 2 times of T of n by 2 plus theta of n. I can apply master theorem. By using master theorem, it is taking time complexity is theta of n log n. That's all. Time complexity theta of n log n. Could you please confirm that are you able to understand the procedure and recurrence equation, everything? Actually, merge sort algorithm, you always interpret in another way. Just observe, friends. The second approach is very important for you. So actually you are dividing this array until the list contains only one element. Only one element. If one element means it's already sorted list. Therefore, you always think merge sort algorithm in a different way. Sorting an array of an element is nothing but merging n sorted list, where each sorted list of size 1. So clearly it is a sorted list of size 1, it is sorted list of size 1, it is also sorted list of size 1. Like that, how many sorted lists are there? How many sorted lists are there? N sorted list. You want to merge this n sorted list into single sorted list. That is the meaning of merge sort algorithm. So based on this merge sort algorithm, we are having applications which I already explained in the class. You can go through it, friends. Okay. So that's what about merge sort algorithm. And one application is we can find inversions by using merge sort algorithm. Okay. Remember that problem also. In the gate, they may ask question: time complexity for finding inversions. Time complexity for finding inversions using merge sort algorithm. So using merge sort algorithm is taking theta of n log n. This is the best algorithm for finding inversions. Okay. Time comes for finding inversions which take theta of n log n by using merge sort algorithm. You refer that one, friends. Okay. Using merge sort algorithm. It is one of the application. Next algorithm which is Quicksort algorithm. Quicksort algorithm. See the way how we discuss bubble sort is largest, selection sort is smallest, and insertion sort is inserting element, and merge sort is merging elements of single list of size 1 into an array of size n. Clear? So in Quicksort algorithm, it is based on pivot element. It also uses divide and conquer strategy. Suppose I am taking T of n is the time required for sorting n elements. T of n is equals to time complexity for sorting n elements. Right, friends? Time complexity for sorting n elements. Then what type of question they'll ask in the gate paper? See, just observe. Suppose if I consider an array, in Quicksort, generally we are taking last element as a pivot element. Last year DA paper also they asked last element as a pivot element only. So you have to follow Corman textbook. The last element is a pivot element. Okay. So therefore we are taking pivot element or pivot element. This is called pivot or pivot. Clear, friends? Okay. Now there are, based on the pivot element, we are defining into 3 cases: best, average, and worst case. Suppose if I am talking about best case, choose last element as a pivot element, apply partitioning algorithm. After applying partitioning algorithm, just observe, friends. So we are choosing last element as a pivot element. After choosing pivot element, last element as a pivot element, you are applying partitioning algorithm. You know how partitioning algorithm is working. Partitioning algorithm is taking theta of n time. You please refer the notes. The partitioning algorithm responsibility is placing pivot element in its correct place. Placing pivot element in its correct place. For example, if I consider an array having elements, assume that 80 and then 10, 30, 70 and then 90, 60, assume it is 50 is a pivot element. 50 is a pivot element. Now, if I apply partitioning algorithm, this partitioning algorithm will place pivot element in the correct place. Correct place. So, where is the correct place? So, how do you decide the correct place, friends? So, if you place pivot element, the pivot element is placed into the middle position now, middle position. Then left side values are all are smaller than 50, right side values are all are greater than 50. So, what are the elements are greater than 50 means I can say 80, 70, 90, okay, 80, 70, 90, they are greater than 50. Let me take it as something like 40, friends, okay, 40. Clear? So, therefore, you select last element as pivot element, apply partitioning algorithm. As a result of applying partitioning algorithm, this element is placed into the middlemost position like this, middlemost position like this. Then these are the elements which are smaller than 50, these are the elements which are greater than 50, greater than 50. But we do not know what is the order of those elements. In that case, I can say pivot element is placed in the correct place. But to place pivot element in the correct place, which algorithm we are using? Partitioning algorithm. You are using partitioning algorithm. The partitioning algorithm will take time complexity is theta of n. Theta of n. Now, based on the location of pivot element, the time complexity is classified into two categories: best case and then worst case. So, when do you set a best case? Suppose if the selected pivot element placed in the middlemost position like this. If the selected pivot element is placed in the middlemost position, by applying partitioning algorithm, which is taking theta of n time, theta of n time, then array is divided into two equal parts, left subarray and then right subarray. The way how I explained here, the same thing I am discussing in this case. Therefore, in that case, recurrence equation T of n is equals to time complexity for sorting n element is equals to first place pivot element in its proper place by using partitioning algorithm with theta of n time. Place pivot element in its proper place by using partitioning algorithm with theta of n time. After placing, left part contains n by 2 elements. Left part contains n by 2 elements. Therefore, time required for sorting n by 2 element is T of n by 2 recursively. Okay. And right part also contains n by 2 elements. Time required for sorting n by 2 element is T of n by 2. Right, friends. Therefore, left part will take time is T of n by 2. Right part will take time is T of n by 2, which is equals to 2 times of T of n by 2 plus theta of n, which is taking theta of n log n, like as merge sort. Have remembered merge sort also we are having same recurrence equation. But what is the difference between merge sort and quicksort algorithm here? Just go through the merge sort algorithm recurrence equation. In merge sort algorithm, first we are finishing left part followed by right part. Afterwards, we are merging these two into single sorted list. Correct? First finish left part followed by right part and then merge them into single sorted list. Whereas in quicksort algorithm, you are reading in the reverse order. You are reading the reverse order. First finish theta of n time partitioning algorithm to find the location of pivot element. Afterwards, if it is placed in the middle position, left part take T of n by 2, right part will take T of n by 2. That's all. Now, second case, for example, if array elements are already in the increasing order, like for example 10, array elements already in the increasing order. Then which element we are choosing pivot element? Last element we are choosing pivot element. Afterwards, we are applying partitioning algorithm. Partitioning algorithm will take time complexity is theta of n time. Partition takes time complexity of n time. With theta of n time, again 50 will be placed in the same place only, right? 50 will be placed in the same place only, right friends? In that case, your array contains elements only elements n minus 1 elements, like we are having elements n minus 1 elements here because only one element is sorted. Therefore, the recurrence equation for this problem is time required for sorting an element is equal to T of n. But which element you are sorting first? Pivot element. Pivot element time complexity theta of n using partitioning algorithm. Afterwards, remaining array is having of size n minus 1. Sorting n elements of size n minus 1 is T of n minus 1. Therefore, it is taking T of n minus 1. Right friends, T of n minus 1. This is a case if array elements in the increasing order, right? Suppose if array elements are decreasing order, like decreasing order means I can say 50, 40, 30, 20, 10. Right friends, if array elements are decreasing order, set the last element as a pivot element, apply partitioning algorithm which takes theta of n time. But is it placed in this place? No, right? Because smallest element. So therefore, smallest element must be placed here. Partitioning algorithm will shift to the first place, where partitioning algorithm will take time complexity equal to theta of n time. Theta of n time. So therefore, after placing, we are having only right subarray this time. So right subarray, how many elements are there? N minus 1 elements are there. Then time required for sorting n minus 1 element is T of n minus 1. Therefore, in this case, the recurrence equation is T of n is equal to placing pivot element will take theta of n time. Afterwards, right subarray contains n minus 1 elements, that is theta of n minus 1. That's all. Both the case will have same recurrence equation. After applying solving process, recurrence like what we call substitution method, we can say theta of n square. It is also theta of n square. Apply first iteration, second iteration up to kth iteration, you will get theta of n square. So from this analysis, you can understand Quicksort algorithm taking worst case behavior if array elements are in the increasing order or in the decreasing order. If array elements in the random order means neither increasing nor decreasing, it takes only n log n time. This question asked multiple times in the gate paper, multiple times. Okay, so we can expect questions based on this topic as there is an array having elements are 5, 4, 3, 2, 1 and another array of elements 1, 2, 3, 4, 5. Time required for sorting, first one is T1, time required for sorting, second one is T2. Then what is the relationship between T1 comma T2 they are asking. What is the relation between T1 comma T2? Obviously they are equal, right? Because one is in the increasing order, another one is in the decreasing order. Therefore, answer to this question is T1 is equal to T2, right? So this is one way of asking question. And second way of asking question, T1 may be decreasing order, T2 random order like 3, 1, 4, 2, like this random order, neither increasing nor decreasing. In give me 1 minute. Yes. So neither increasing nor decreasing. Obviously, quicksort takes more time if the elements are in the increasing order, decreasing order. Therefore, answer to this question is, I can say T1 dominating T2. So these type of questions you can come across in the gate paper, friends. Okay, gate paper. And applications oriented point of view, here we are choosing pivot element, right? So based on the pivot element also, they ask 3-4 times in the gate paper. Let me discuss those questions. But could you please confirm that if everything is clear so far? If everything is clear so far, what you will type? You can type something like, you type L in the chat box. Type L in the chat box, friends. Okay. Right. Thanks for your response. Okay. Now, what type of question they are asking based on this topic? There are different models questions they ask so far based on this topic. Let me discuss them. One time they are asking question. One time they ask the question this way: if we choose central element as a pivot element, if we choose central element as a pivot element, then what is the worst case time complexity of quicksort? So this is the way they are asking questions, friends. Okay, if we choose central element as a pivot element. Next time, one time they ask question, if we choose median, as pivot element, where median already selected, using order of n type algorithm, then worst case time complexity of quicksort. Clear, friends? Okay, here it is central element, here they are talking about median as a pivot element. Okay, next one, another way of asking question, I'll use different color. If we choose n by 4th smallest element as a pivot element, using order of n or theta of n time, then worst case time complexity of Quicksort. They may ask question like this. Okay, they already asked. Okay, they already asked this model. Next one, a randomized Quicksort algorithm. That is randomly selected pivot element. Then worst case time complexity of Quicksort. That's all, friends. Okay, these are the different types of model questions came so far in the GATE paper based on Quicksort. It is very simple to answer each and every question. Just observe, friends. Okay, do you want to answer? Do you want to take some time? Now 12:05. Can you take 2 minutes and answer first question, second question? You can say question number 1. It is question number 2, question number 3, question number 4. Just can you answer one by one? If you choose central element as a pivot element, just look at here in this problem. I am taking an array having elements are 40, 50, 90, 10, 30, 20, 25. Just imagine like this. Now we are choosing central element as a pivot element. After you are applying partitioning algorithm. Partitioning algorithm will take time complexity is theta of n time. Then where is a proper place for 10? Obviously smallest element. Smallest element must be in the first place, right? Therefore, it should be in the first place. So it is the first place, therefore it is shifted to first place here. Therefore, remaining elements are, how many elements are there remaining? N minus 1 elements are there. Therefore, recurrence equation is time required for sorting an element is T of n. By applying partitioning algorithm, we are placing 10 in the proper place. Therefore, partitioning algorithm will take time is T theta of n. After placing, we are having n minus 1 elements here. N minus 1 elements. Therefore, time required for sorting n minus 1 elements, we can say T of n minus 1. That's all. Okay. By solving this problem, we will get theta of n square. Therefore, choosing central element does not give guarantee it will be stored into central position. It may placed into extreme left or it may placed in extreme right. Choosing central element as a pivot element does not give guarantee it is placed in central position only. Okay. Next one, they already found median with order of n time. They already found median as order of n time. Therefore, in this case, what happened? They have already chosen median as a pivot element. Therefore, you know median means middlemost element. Middlemost element. Therefore, after applying partitioning algorithm also it is placed in the same position. Same position. But if partitioning algorithm will take how much time? Theta of n. You can go through the notes how it is taking theta of n time. Therefore, it will divide into 2 equal parts. Right, friends? Okay. So this part will take t of n by 2 time. This part will take t of n by 2 time. T of n by time. Therefore, recurrence equation for this problem. Time required for sorting an element is t of n. First, they already found median with order of n time. Order of n time or theta of n time, what it may be. There is a procedure for finding median with theta of n time. That is selection procedure is there. Okay. Therefore, median found in theta of n time. After finding median, now they are applying partitioning algorithm for placing median in the proper place. Therefore, partitioning algorithm will take theta of n time. Partitioning algorithm. After placing, then left subarray contains T of n by 2, right subarray contains T of n by 2. Therefore, T of n by 2 plus T of n by 2. Like this, okay. So, which is equals to 2 times of T of n by 2 plus theta of n. Right friends, 2 times of T of n by 2 plus theta of n. So, which is known as theta of n log n. Right, theta of n log n. It is for finding median which they spent theta of n time. After taking median as a pivot element, apply partition order which take theta of n time. Then it is divided into equal parts. That's all. Next, if n by 4th the smallest element selected as pivot element. So, we are taking, this is suppose pivot element. This pivot element placed into n by 4th position, because you know, suppose 100 elements are there. 100 elements are there. 100 by 4th element means that equal 25th element. 25th element is the 25th smallest element in the meaning. Okay. Therefore, n by 4th the smallest element means compulsory it must be placed in n by 4th position only. N by 4th smallest element compulsory placed into the n by 4th smallest place only. Okay. N by 4th place only. So, if it is placed in n by 4th position, left part contain n by 4 elements which is sorting T of n by 4, where right part contain remaining elements that equal T of 3n by 4. Right friends, but placing that element which takes partitioning algorithm theta of n, okay. Therefore, time required for sorting an element equal to T of n, okay. Right friends, and then finding n by 4th smallest element theta of n, applying partitioning algorithm will take theta of n, left part will take T of n by 4, right part will take T of 3n by 4. Okay, let me write this one proper way. T of 3n by 4. Have remembered T of alpha n plus T of 1 minus alpha into n plus theta of n, which I explained today morning class. So, by using that approach, it is taking order of n log n base 4 by 3. Kindly refer that formula, alpha n plus 1 minus alpha n formula. Today we discussed that part. So, that's all about n by 4th smallest element. See, whatever n by 4th, n by 10th, n by 100, n by 200, anything it is taking n log n only. It takes n square only 2 cases. Either elements are in the decreasing order, elements in the increasing order, then only quicksort takes theta of n square time. Okay. Next, afterwards, a randomized quicksort algorithm. You know, randomized quicksort algorithm means we are using random function. Just we are using random function. So, by using random function, we are using a rand function from the lower index. Suppose P is a low index and Q is a upper index according to our class notes P comma Q. We are having some random index from P to Q. We are taking that value in X. Afterwards, what you have to do? For example, your array contains please refer my class notes, you can understand. Array contains elements are P to R. Just imagine that P to R. P to R. Then we are selecting randomly one index that is stored into X. Afterwards, what you have to do? You can swap the elements. Swap A of X element with whom? A of R. It means, for example, you are taking X index is randomly, this is the element you are taking, for example. Now swap these two elements. Get swap these two elements. Afterwards, apply quicksort algorithm process. That's all. Therefore, what is the worst case time comes quicksort? Theta of n square. So, swapping will take only constant time. A random function takes constant time. Therefore, worst case time comes of quicksort, that is theta of n square only. Theta of n square. Okay. So, these are 4 types of questions they frequently ask in the quicksort. If all 4 questions are clear, simply type 4 in the chat box. not FOR, only digit 4, simply digit 4. My voice is coming, Gautami. Simply digit 4, enough, we don't waste time. You want question 4, Shubhashis? Question 4, actually it is have you studied my class notes? In the class notes I provide quicksort algorithm, right? In quicksort algorithm, extra you apply 2 lines. Random function from P to R, it is giving one random index x, then swap with the last element, remaining algorithm as it is only. So worst case time comes, what is that? Theta of n square. That's all about quicksort. We successfully completed. Actually, it is very nicely completed quicksort. I really like it. See, when it comes to heap sort, I don't want to discuss complete algorithms here, because the workflow for heap sort is, first you need to understand definitions of max heap, min heap. Definitions of max heap, min heap. So max heap is nothing but parent always having key values greater than the key values of children. That is called max heap. For example, max heap is looking like this. Suppose if it is 20, 20 should be greater than its children. Maybe it is 10, it is 15. But there is no ordering between the children's. There is no ordering between the children's, okay? And here, if I take 10, 10 must be greater than children. We can take it as something like 8. Here I can take something like 6. But there is no comparison between siblings. And 15, if I consider, it may be 7 or it may be 4, like this. And it must have 2 properties. First property, it is a complete binary tree and it is satisfying parent always greater than children. That's all. This is called max heap. Apply same property for min heap also. Parent must be smaller than the children values. That is called min heap. Definition is over. Afterwards, inserting next you have to understand construction of heap tree. See, construction of heap tree we can do in 2 different approaches. By inserting keys one after another, right, or by using build max heap algorithm. First method, by inserting keys one after another. This is first method. It is compulsory they are using this word one after another. Okay, if you insert keys one after another, construction of heap tree will take time complexity is theta of n log n. Construction of heap tree will take theta of n log n. For example, if you ask me to construct heap tree by using keys 20, 50, 80, 36, 44, and then 58. I want to construct a max heap. I want to construct max heap. So first I can insert a key 20. By default it is satisfying heap tree property. Next, where I have to insert 50 means insertion always happen from left to right. Why insertion is happening from left to right? Because by default it is a complete binary tree. If it is a complete binary tree, insertion always happen from left to right. Therefore 50 I am taking. After inserting, compare with the parent. Since you want max heap, parent should be greater than children, but parent is not greater than children. Then you can interchange those elements, okay? Exchange these elements. After performing exchange operation, we are having 50 and then 20. We are performing comparison and then we are interchanging these two elements. That's all, okay. So this is the step we are getting. Afterwards, insert 80. Where we have to insert 80? Insertion always happens from left to right. Insert 80. Afterwards, compare the parent. But parents should be greater than children. That's why interchange these two elements. 80, 20, then 50. Afterwards, next one is 36. So 36 must insert in the next level because complete binary insertion happen from left to right. Insert 36. Afterwards, compare the parent. They are not in the proper order. Parent should be greater than children. Therefore, interchange these two. Now it is 20, 36. Again, compare 36 with parent. Yes, they are in the proper order. They are in the proper order, right, friends? Okay. Therefore, after this, we are having tree in this way. I think it's not looking good. We are having 80, 36, 50, then 20. What about next one? 44. Insert 44. So insertion 44 from left to right. Afterwards, compare these two elements, perform interchange. That is 44, 36. Again, compare the parent. No need to perform any interchange. I think that's enough. No need to go for further iteration. I'll remove this one. Right, friends? Okay. Therefore, final tree, we are having 80, 44, 50, 20, and then 36. So this is the way how we are constructing heap tree by inserting elements one after another in the given order. Is it clear, friends? Okay. Then I want to discuss time complexity and its performance. Okay. Just observe, friends, how I am explaining time complexity. Suppose we are having heap tree with already n elements. Now I wish to insert one more element. In that case, how we are performing comparison? Just verify. For example, here it is 100, let it be 80, 70. Now I want to insert 120. I want to insert 120. Then how many comparisons I am performing? How many swappings we performed? Comparisons means 120 is going to compare with 70, first comparison, and then perform interchange. That is swap these two elements. 70 and then 120. So 120 is going to compare with 80, perform interchange. It is 80, 120. 120 compare with 100, swap these two elements, 100 and then 120. Clear, friends? In this entire process, how many comparisons means 1, 2, 3 comparisons. Comparisons are 3. How many interchanges? 3 interchanges. But we cannot express time in terms of constants. We have to express in terms of input values. Therefore, in the place of 3, I can also say height of this tree. Just observe what is height of this tree. Like 1, 2, 3. Height of the tree. But in the last class, we already discussed that maximum height of complete binary tree always bounded by log n. Therefore, instead of writing 3, I can also say height of the tree. Height of what type of tree? Complete binary tree. Therefore, this is equivalent to height of complete binary tree means log n base 2, which equals to log n base 2. Therefore, the total time required for inserting element is theta of log n base 2 plus log n base 2, which equals to 2 log n base 2. There is no importance of 2, I am taking theta of log n base 2. So, inserting one element will take theta of log n base 2. But are you constructing heap tree with one element or n elements? N elements. Therefore, we can continue like this. Right. So, one element insertion takes log n, correct friends, okay. But I want to construct heap tree with n elements. Therefore, time required for constructing heap tree. Theta of n log n base 2. That's all. Theta of n log n base 2. So, this is the first model friends, okay. If model 1 is clear, type 1. 1 stands for model 1 is clear. Next one, second method. It is a first method. Construction of heap tree is a first method. The second one is you have to convert array into max heap. They will provide array, we have to convert into max heap. That is called build max heap algorithm. Method 2, that is by using build max heap algorithm you have to convert. It means that they will provide an array, convert array into max heap. Clear? Let me take simple example you can understand. Suppose you are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are there. Randomly I am taking elements friends, okay. Randomly I am taking elements, okay. Now in this case, if n is equals to 10 elements are there, you need to identify where leaf node index is starting, where non-leaf node index is starting. Please recall the array representation of complete binary tree. If there are n elements are there, highest index of non-leaf node, highest index of non-leaf node, highest index of non-leaf node is equals to floor of n by 2. Floor of n by 2. Highest index of non-leaf node is floor of n by 2. So, floor of n by 2 is 5 by 2, 10 by 2 that equals to 10 by 2 that equal to 5. So, it is the highest index of non-leaf node. The remaining indexes are leaf node indexes, okay. So, these are leaf node indexes. By default, all leaf nodes are satisfying heap tree property. That's why no need to apply any heapify algorithm on leaf nodes. Clearly, no need to apply heapify algorithm on leaf node. We can apply heapify algorithm starting from highest index of non-leaf node. So, starting from here, we can move towards root node position. That's the reason in our for loop it is taking for I is equals to floor of n by 2 Okay, floor of n by 2. I greater than or equals to 2, I minus minus. Sorry, I greater than or equal to 1. Assume that root node index starting from 1. I minus 1. So what we are going to do here, you are calling Heap algorithm, max Heap algorithm, an array, an index I. That's all. You are applying max Heap algorithm on index I. Where you are starting? We are starting from highest index of the non-leaf node. Let me take this one now. So root node is equals to 15. I think how many elements are there here? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 means 5. Okay. 1, 2, 3, 4, 5. 15, 8, 36, 42, 58, 64, 80, 14, 9, 14, 19, 24. So generally in the array representation, we are taking root node index is 1. Okay. So root node index 1, 2, 3, 4, 5. Remaining are leaf nodes 6, 7, 8, 9, 10. Clear friends, remaining are leaf nodes. Suppose let me take one more element, you will get more clarity. 11th index also. So 11th index also I am taking 29. Right friends, okay. So Heap algorithm says that Heap algorithm, you have to apply from highest index of non-leaf node, because by default leaf nodes already maintain heap tree property. That's why no need to apply. So you can apply max Heap algorithm starting from 5th index. What is max Heap algorithm? Just observe friends. In this max Heap algorithm, how exactly working? We are applying max Heap an array at 5th index. Very simple friends. You have to bring largest element to the parent position. That is max Heap. How to bring largest element to the parent position? Compare 58 with 24. Largest is 58. That largest you are going to compare with remaining child. That's all. Okay. So first compare parent and left child. Hold the largest between these two. That largest is going to compare the remaining element. Therefore 58 and 24 largest is 58. Then 58 and 29 largest is 58. That's why no need to exchange the elements. That's all. Heap of this one is completed. Now we have to continue this process. After I equal n by 2, now we are decrementing I by 1. Decrement I by 1 means I becomes 4. I becomes 4. So now you had to apply Heap algorithm on 4th index. Okay. Apply Heap algorithm, max Heap algorithm, max Heap algorithm, an array at 4th index. Now comparison between 42 and 14, largest is 42. That largest is going to compare the remaining element. 42 and 19, still largest is 42 only. That's why no need to perform any adjust operation. Okay. Now you can apply Heap algorithm on 3rd index, max Heap an array at 3rd index. Right friends, okay. 3rd index. So 36 and 64 is going to compare. Who is the largest? 64 is the largest. If 64 is the largest, then 64 is going to compare the remaining element, that is 80. Now that 80 become largest, that 80 is going to swap with the parent. That's all. This is the way you need to continue this process. Okay. So I don't want to continue because you understood the process, right? And in this case, max Heap algorithm, actually max Heap algorithm takes log n time. Why it is taking log n time? For example, if you apply max Heap on root node, there is a high probability that that element may be moving towards leaf place. So therefore that equal to height of the tree. Height of the tree. Height of the what type of tree? Complete binary tree. Therefore max heap if algorithm which is taking log n time, theta of log n time. Right friends. But how many times you are applying this algorithm? Maximum n by 2 times you are applying. Therefore the time complexity for this problem, theta of n by 2 times you are applying, n by 2 times you are applying, because starting from n by 2 up to 1, n by 2 times you are applying. Each time it is calling max CP5 which is taking log n. Theta of n by 2 into log n. Theta of n by 2 into log n, we can also write theta of n log n. By ignoring constant, we can say theta of n log n. Means initially mathematician also falls under illusion that it is taking theta of n log n time. But in fact, we are not calling heapify for leaf nodes, right? We are not calling we are not calling heapify for leaf nodes. That's why they change the analysis in different way. The different way is, in the worst case, 15 is moving towards leaf place. That is nothing but height of that node. Height of any node equal to longest path from node to leaf node. Okay. So similarly, if I apply heapify here, it will move to leaf level. That is height of this node. Therefore, can we do better analysis for this? Means yes, we can do better analysis. Here they are asking, can we do better analysis for this? Yes, we can do. So here they did better analysis is, instead of doing heapify, they are asking sum of the heights of all nodes. Okay. So that is sum of the heights of all nodes. Sum of heights of all nodes. You know, sum of heights of all nodes bounded by theta of n. In this data structures, I explained clearly this part. Therefore, construction of heap tree, first method theta of n log n, second method is taking theta of n. That's all. Okay. This is all about in construction of heap tree. Next one, heap extract max operation. Heap extract max operation. So how to extract max element from the heap tree? Okay. So for example, just imagine, friends. It is a max heap. Right. Okay. Heap extract is nothing but max heap extract means you have to remove the first element and copy it into max. Max is equals to a of 1. Max is equal to a of 1. Right, friends. After copying a of 1 into max, then you can replace a of 1 with the last element. That means a of 1 is replaced with a of a dot heap size. A dot heap size. Heap size means total how many elements? 1, 2, 3, 4, 5, 6, 7, 8, 9. Heap size is 9. Therefore, a dot heap size meaning is a of 9th element. Okay. So it is nothing but it is 9. A of 9. Means you are replacing 100 with 20. 20. After replacing, the tree is looking like this: 20, 80, 40, 60, 50, 30 and then 20. Here we are having 35. So simply copied max element into a of 1 max element, and the max root element is max element, right? Therefore max is equal to a of 1. Afterwards you are replacing a of 1 with a of a dot heap size. A dot heap size means 9 elements are there. Means a of 9 copied into a of 1. Afterwards what you have to do, everything else is satisfying heap tree except root node. Just verify it is by default heap. it is satisfying heap tree property, it is satisfying heap tree property. Only root node not satisfying heap tree property. That's why root node index is 1 here. You can apply max CP5 algorithm again. Apply max CP5 algorithm. An array at first index. That's it. Right? How to apply max CP5? Comparison between these two, largest is 80, 80 and 40, largest is 80, interchange these two, 80 and then 20. Comparison between these two, largest is 60, 60 and 50, largest is 60, therefore interchange these two, 60 and then 20. 20 and 35, yes, largest is 35, interchange these two, 35 and then 20. This is called Heap algorithm. So max CP5 is moving 20 to the leaf node. Therefore, maximum time is equals to height of the tree. Therefore, max CP5 algorithm will taking height of the tree which equal log n. Okay. Therefore, extract max element will take time compress equal theta of log n. What type of question they ask based on this topic in the previous year gate papers? One time they ask question is, if only root node does not satisfy heap tree property, if only root node does not satisfy heap tree property, then what is the time complexity to convert complete binary tree into heap tree? For example, here only root node does not satisfy heap tree property. Then what is the time complexity to convert this complete binary tree into heap tree? That is nothing but apply max CP for one time. That's enough. Theta of log n. That is one question they asked. Second one, they ask question like, which of the following is the array representation of the max heap? They're asking. For example, friends, just imagine if it is a array, if it is a heap, array representation of max heap they're saying like it is at 100. It is also one important area, 100. Next element is 80, 40. Then next 60, 50, 30, 20, 35. I think I have taken 22 times, right? No problem. You can change it. You can make it as something like 19. You can change it to 19. Okay. (13, 19) and then 20. This is called array representation of heap. Array representation means level by level you can consider. So 100, 80, 40, 80, 40, then 60, 50, 30, 60, 50, 30, 90 and 35, 20. In the exam they will ask options like this, which of the following is array representation of max heap? Then you can verify 100 greater than 80, 40, satisfied. 80 greater than 60, 50 in max heap, it is satisfied. 40 greater than 30, 19, yes, satisfied. 60 greater than 35, 20, satisfied. This is the way you need to verify. So in the exam, what they ask question based on extract max, they provided array representation of max heap. If you perform 2 times deletion operation, what is the content of the array after performing 2 times deletion operation? Here, after performing 1 time deletion operation, what is the content of the array? After 1 time preparation, content of the array is 8 and then 60, 40 and then 35, 50, 30, it is 19, right friends, okay, then 20. That's all. It is the content of array after 1 deletion operation. Like that they are asking 2 deletion operations. If I apply 1 time extract max operation, I am getting first largest element. I can store it into nth location, right? Like that you can apply n minus 1 times, you will get n minus 1 largest elements, which is in the sorted order now. That's all. Heap sort completed, right? So heap sort algorithm is nothing but you can apply this process. First time you get first largest, second time second largest. You can refer the class notes also, okay? So heap sort time complexity is theta of n log n, friends. Heap sort time complexity theta of n log n. So that's all about heap sort concept.